93% of developers use Git, which actually feels to me a little bit low, because 100% of the developers that I've worked with use Git. It's got a tighter grip on the version control industry than Google does on your personal data. In this video, ThePrimeagen is going to walk you through not one, but both of his Git courses. I'll try to keep this intro short because Prime does a better job of talking in front of the camera than I do, but I just wanted to let you know what you're getting into. Now, in each course, there are 11 chapters, which means 22 chapters in total. You'll learn how to set up Git, what repositories are, Git internals, Git configs, branches, how to merge, how to rebase, Git reset, what remotes are, how to use GitHub with Git, and ignoring files with Gitignore. In the second half of the course, you'll learn how to fork a repo, how to use Reflog, merge conflicts, rebase conflicts, squashing, stashing, reverting, cherry picking, Git Bisect, Git Worktrees, and tags. It's a lot. The first half of this course, Prime's course number 1, is really all about learning how to use Git as a solo developer, and course number 2 covers all the stuff you need to know to use Git effectively in a team. Prime has spent over 8 months writing these courses, and the rest of the boot dev team and I have spent that same amount of time really helping to edit, test, and refine them. So I hope you enjoy them. But this is a very interactive course. I do not recommend sitting down and binging it in one sitting. There are interactive lessons and projects the entire way, so get your hands on the keyboard and actually follow along. In fact, I actually recommend that you take the course on boot dev and go ahead of Prime, and then watch him go through that same lesson so that you can see his approach, his commentary, and his solutions after you've had a chance to experiment and challenge yourself and do it yourself. Now, all of the content in this YouTube video and all of the content on boot dev are completely free. There's no need to sign up for a boot dev membership to get value out of this course. That said, all of the interactive features on boot.dev are paid features. So if you want to be able to submit your own assignments, if you want to view solutions, chat with the AI chatbot, or get a certificate of completion at the end, you will need a paid membership for that. And you can actually use ThePrimeagen's code, PrimeYT. That will not only help us at boot dev be able to produce more courses like this, but that also supports ThePrimeagen directly. That code, PrimeYT, will get you 25% off your first month or year if you choose an annual plan of a boot.dev membership. One last note, if you get stuck and need help, our Discord community is literally just a few clicks away. So join the Discord community, ask for help, and let's talk about Git.
All right, we are now going to officially start the entire boot.dev Learn Git. I'm gonna go through the course that I created. I wanna do it, and it's gonna be awesome. Here we go, we're gonna go through the course. We're not gonna watch the videos because guess what? This is my course. In 2005, after license disputes with BitKeeper, Linus Torvalds, creator of Linux, you may have heard of it, sort of runs the web, not a big deal, decides to write his own version control. He wrote Git in 5 days, and within a couple years, it became a widely used version control, and now, today, it is the de facto standard for all developers. To be clear, when I say Git, I don't mean an insult from across the pond, and I don't mean GitHub, GitLab, Stash, or any of the others. All of those companies use Git. They are not Git. Git allows you to track code changes over time by author with a set of commands to search, manipulate, and revert history. In simple terms, Git creates a commit. A commit is just a set of changes tied to an author, time of day, and other information. As many commits as you want can be added to the graph. At any commit, you can branch off and create new commits on the new line. Any of these branches can be merged into any other branch, including the main line. Commits can be squashed into one commit, and commit messages can be edited. Also, Git commits can be reverted, just in case they don't want terrible code. Git is a very complicated piece of software, but the interface and operations are very simple. And in this course, we're going to be going over installing and configuring Git, porcelain and plumbing commands, inspecting Git history, branching, merging, and rebasing, undoing changes, and remote repos and GitHub. I hope you enjoy this course, and in about another month or two, I will be releasing part 2, which will go over all the advanced features, advanced techniques with merges and rebases and conflicts, and of course, just really diving into some of the more complex parts of Git. But in this course, you should be able to get everything you need to become quite proficient in the real world, including understanding how Git works. The name is the Gitignore. I already have everything done. I might need to update boot.dev. Hold on one second. All right, there we go. I'm gonna get the latest version. Here we go. Go install. I thought that was a thing. Anyways, okay, there we go. We got the new boot.dev. Everything's looking good. Let's do a little boot dev version. Oh yeah, looking hot, looking good. Perfect. I believe I should all be logged in, so I'm just gonna go like this just to make sure that I'm logged in. There we go. Echoing rebasing is base. There we go. Everything good. I believe I'm all good. Perfect. Okay, submit. So this is the cool part, by the way. So this tool was developed, I think the motivation started with my course and other courses. I think Lane was developing one that also needed it as well. But this tool is super cool. So you copy this thing, you paste it in, and when you go right here, look at that. It says, hey, you did everything correct. Okay, fantastic. All right, we've already installed Git. I already have everything installed. I don't need to worry about any of that. All right, we'll do that thing as well. Okay, perfect. The CLI is so cool. It is. All right, read the friendly manual. One of the best parts of Git is that all the documentation is fantastic, but that wasn't always the case. By the way, it was actually the Git documentation. To this day, I actually can't read the man git tag page still. Okay, so everybody knows what a tag is, right? We all know what a tag is. Let's see, add a tag reference in ref tags unless DLV is given to delete, list, or verify tags. Okay, I think we understand this, right? Unless F is given, the named tag must not yet exist, and then this has happened to create a tag object that requires tag message unless M or F file is given and editor is started for the user. Okay, what the hell is a tag, though? Can you just tell me what it is? Otherwise, a tag reference points directly to a given object. I know, it's just like, is this just wild? I'm surprised the very first description isn't being like, a tag is a immutable named pointer. I'm just like, what the fuck is this? All right, who created Git? Obviously I did. Ah, shit. By the way, Linus Torvalds did create Git in 5 days, and the story goes like this. He created Git in 5 days because one of the maintainers of Linux broke the BitKeeper's license to Linux. BitKeeper said, you can use BitKeeper, you're just not allowed to reverse engineer the protocol. And somebody reverse engineered the protocol, and BitKeeper said, get the hell out of here. Get out. And so they actually had no more subversion at that point, or whatever BitKeeper was. So he wrote to Git in 5 days. Now remember, Git was not friendly at all. You had to use all the plumbing, right? You had to use cat out the file. You had to create the tree. Like, you had to do all the tracking yourself, and it was not fun, right? It was not good. It was not good. But anyways, Linus did it all in just a moment. And he did it in 5 days. Then on the 6th day, he rested. Porcelain and plumbing. For whatever reason, Git is compared to the crapper, R.I.P. John Crap. And so porcelain's the outside, the good stuff. The plumbing is like the hard things, the underlying tools you can use with Git. All right, so in Git, commands are divided into high-level commands and low-level commands. The porcelain commands are the ones that you will use most often as a developer to interact with your code. Some porcelain commands are these ones. Don't worry about what they do yet. We'll cover them in detail soon. Absolutely, by the way. Some examples of plumbing are this one. Git apply, git commit tree, git hash object, in which I barely know any of what those things do. We'll focus on the high-level commands because that's what you'll use 99% of the time. In fact, I've never professionally used the lower-level commands, right? Bisect is, I believe, is a porcelain command. Reflog, porcelain command. Cherry pick, porcelain command. It's a bit confusing, right? All right, 99% of the time, porcelain commands are used to interact with Git. Yeah, but you can, and I have done it. But it's really good to understand how they work. If you understand how the plumbing works, the porcelain makes a lot of sense. All right, quick config. We need to configure Git with your information. Whenever you code, yeah, blah, 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 blah. So we got to do this thing. We got to add our name in our config. So if you've never done configuring in Git, Git just has this whole global, it's literally just a file. That's all it is just a file. And it's either in global space, which means it's in your home directory, or it's within your .git folder. So kind of either or there. Anyways, this is pretty good. So we can do this config set username email. So I'm going to make sure, let's see, git config Local, what do I got here? Oh, whoopsies. Is it list local? I always forget how to use this one. Error keys does not contain git config. What is it? It's list. Oh yeah, I forget. List is the only one. Config is the only one that has this older way of doing a bunch of dashes. Whereas like when you use something like git stash, you go like git stash list. Whereas with config, you go this kind of list. And I always have to remember what the hell I'm doing right there. Okay, local. So as you can see, I have all these things. These are all the good stuff. This is from Graphite, so don't mind that here. We're gonna probably want to do stuff though. Git config, list, grep name. Do I have a name in there? I do. I have the name. There we go. I have email. Perfect. Bada bing, bada boom. We got those things already set, so I have all that. And you add it to your global. So your global, by the way, if you just go like this, you can go, whoopsies, git config. Right? It's right there. It just takes the latest value. All right. And so we also have this one. Finally, let's set the default branch. We'll talk more about this. So we're all on the same page. We're going to set the default branch to master to begin with. So the funny part is that, hey now. Let's see. Hey now. The global, and then you have to go, what is it? Is it add? Look at that. There we go. Add. There we go. So it takes the latest one. Probably need to do an add. Might want to make a little note there. Never caught that problem. Only level 2 week. I had to reset my entire account. All right. Make sure it works. So there's a reason why we do this, so we can show you to do it differently later, right? But it's master by default. True, but a lot of people already have it, say, updated to main or to trunk or something else. So I just wanted to make sure that we had this such that everybody can change it and see what it is. So there you go. All right, so we can cat the config. Awesome, you saw that. We can cat the config. Everything looks good. All right, we're gonna kind of rush through these early ones because I don't think they're not that important. And when you're learning how to use Git, these ones don't make a lot of sense. Like, what the heck is this config thing? Why are we setting all these things? We just got to do it to set up your repo so you understand how Git works, right? So this is all confusing stuff. You're probably very confused if you're new to Git. That's fine. It's okay. All right, so the very first step of any project is to create a repository. A Git repository or repo represents a single project. You typically have one repository for each project you work on. It would be wild to see many repositories for a single project, unless if you're considering forks / Webflix, you like that? A repo is essentially just a directory that contains a project, other directory or files. The only difference is that it also contains a hidden Git directory. This was a big eye-opener for me, is realizing that the .git is literally the entire state of your Git project. It's like the entire thing. And so if you're ever having questions about what's going on, everything is actually stored in here. So when you think, oh, how does it know how does it know all my branches? It's literally in the Git directory. Everything about it is in the Git directory. Webflix. In this course, we'll be managing content for Webflix, an imaginary self-hosted video streaming application. Can you imagine? Why would we name it Webflix? That makes no sense. Let's see. Navigate to somewhere in your file system where you'd like to store the project, and once you're there, create a new directory called Webflix. All right. RMRF. I bet you Webflix already exists in my. Oh my gosh! Get the hell out of there. Oh, get the hell out of there. Okay. Make dir Webflix. There we go. And Webflix. There we go. Now I'm in here. It's brand new. Right? It's empty, nothing in here. And so I'm assuming we're going to have to gitinit. Gitinit just creates the new empty directory, right? It doesn't do anything other than it creates a brand new directory. It uses our config. Let's go. So I should be able to go ls-la. You can see a Git folder right here. If I find inside the Git folder, it's pretty empty. It just has all this stuff. It has a bunch of sample pre-hooks. It has no objects, which is where it stores everything. It has nothing. I believe even the head is a little bit goofy, if I'm not mistaken. There you go. That was weird. Cat git head. There you go. Weird, huh? Getting it. Yeah. All right. So anyways, we do all this one. Awesome. So now that we have our repo initialized, let's actually get into the stuff. Is this VOD going to stay online? It's actually going to be moved to the boot.dev YouTube. There we go. We got all this. This looks good. Let's go. Return to our browser. Done. Got him. Man, I'm so good at this. I'm getting so much stats. Look at this. I'm already level 2. A file can be one of the several states. Let's see. A file can be in one of several states in a Git repository. Here's a few important ones. Untracked, staged, committed. Okay, this is very important. This is also very important to understand because I've lost so much work not understanding the difference between all of these. All right, the git status command shows you the current state of your repo. All right, so assignment. Every good content management system needs a table of contents. Create a file in your root called contents.md and add the following lines. Let's do this. All right, vim contents.md, paste this thing in, bam, bam, git status. You'll see right here, untracked files. That means Git doesn't know anything about this. This file, an untracked file means that it's never been added to the index, which is like your staging area, or it's never been tracked. So it just says we don't know what's in it. So if you delete this file, you lose every last bit of content. Because I'm pretty sure there's been a lot of people that have goofed that up. Yeah, I've done it. It hurts. It's emotionally a bruising experience to accidentally have a file that was untracked. You think it's tracked. You do something and you delete it and it Fs you. Removed untracked files? Yeah, removing untracked files is emotionally painful because you can't really recover it. It's a rite of passage. It's a rite of passage to emotionally bruise yourself. All right, there we go. So now I should be able to jump in here. I should be able to run the little tool. There we go. Everything's good. All right, so staging. Staging, you'll notice the term index a lot. So if we go into here and we go man-git, what's it called? Add. You'll probably notice the word index quite a bit in here. And the index is literally just the changes that you have staged onto your system. That means any untracked files become tracked files, and only the entire changes are tracked at that point. There we go. Add this one. Let's see. For example, I use Arch, by the way, right? Without staging, every file in the repository would be included in every commit, but that's often not what we want. All right, so you want to git add the file. So I'm going to add the contents and then do this. Now, me personally, whenever I do stuff, I usually hit a git status if the tree represents what I want it to be, meaning that the changes are what I want, and we have just this one untracked file. I often will just use git add this. Now, here's the deal about git add, okay? That's a little goofy, all right? Git status. When you do this here, I'm going to go like this. I'm going to go touch foo. If I go like this, git status, you'll notice that foo's untracked as well. If I make dir foo and cd into foo and then git add this, you'll notice that foo remains untracked. That's because git add dot adds everything at that directory and beyond. It doesn't add things in the directory path. You have to use different ones like git add capital A, that kind of stuff. But we're not talking about that, okay? We're not talking about that. There you go. Get the hell out of here. There we go. Status, we got that. Fantastic. So I should be able to just run this. We've now added it. Our contents have been added. We're looking good. We're looking good. Oh man, I'm getting so much experience points. I'm almost level 3. After staging a file, we can commit it. A commit is a snapshot of the repository at any given time. So this is very, very important, and this is a thing that a lot of people don't understand about Git. Git is not storing diffs. Git stores the entire history per commit. So your entire Git, everything, is in a single commit. And that's very, very important distinction to make because a lot of people don't realize that. Okay, so our assignment is commit the contents of file this with the message add contents this. You wouldn't normally start a commit message with A. Obviously, this is because we're doing stuff with boot.dev, so it wants to be able to keep track of all your commits and all that. So there we go. Then run git status scan. You should see that the file is no longer staged, right? All right, so let's go back here. Let's zoom in. Git commit. Let's see. Git commit. There we go. We did that. And so if I go git status, you can see we have a clean working tree. Git log one line. You'll see that we have one thing right there. Let's see. Wait. So it doesn't store a per change commit? No. And density, I'll show you why in just a moment. So this course is meant to really show you what is going on here. All right. So now that we have that, I should be able to just take this boot.dev, paste that in there, go right here. Awesome. I did it. I'm smat. I'm real smat. Half of Git. You've learned half of Git. You've literally learned half of Git. We just git commit status, add, commit. Right? That's all you need to know. Status, add, commit. That's like most of Git. I know that's crazy to think of, but that's it. Half of Git. Easy. You're like a senior engineer at this point. It's not near half though. I know, of course, it's not actually near half because when you go like this, git. When you go like this, man, git dash, you'll notice that there's 151 possibilities. But of those possibilities, 3 of them is what you pretty much use constantly. Which commands adds a file to the staging area? Prime? Is it prime? No. Add, right? It's in the name, dummies. It's in the name, dummies. All right, git log. Okay, log is fantastic, by the way. Log is one of those sleepers that people don't know how to use, but there's so many good stuff to a log. Git repo is a potentially very long list of commits where each commit represents a full state of the history. A git log command shows the history in a repository. This is what makes Git a version control system. You can see who made the commit, when the commit was made, and what was changed. So there's a lot of cool things. So here, so this right here, we'll see what he made us do. This goes git no pager. I believe this just simply will output the git log. So normally when you do git log, it actually outputs this like second screen. That's kind of like less. If you've ever used the tool less, that's all it's doing. Instead, no pager just prints it directly out. It just prints it to standard out. And log is the command. N10 means the last 10 commits. But what you really want to do is you can do things like one line. That will make it nice and smooth, so you can just see this nice, beautiful thing. You can do parents, which will do annotation. We don't have any parents yet. We don't got no parents. We are the Batman of commits. There's a bunch of stuff. Graph is really cool if you're working on something, because graph you'll notice that there's like a little asterisk right here. It will actually graph how your commits are being merged back in and how the different branches are going. So we're orphans right now. We're effectively orphans right now. Or you can think of us like Adam. Maybe we're the first. Huh? It's not that bad, right? Right? All right, do one of those. There we go. Bada bing, bada boom. All right, so let's get into some real stuff. Different hashes. My latest commit, so in this example, the commit hash was this. Our commit hash was what? 78, blah, blah, blah. And that's because whenever you do anything with Git, the hash you can technically do a hash collision by being able to generate the same Git changes from the same author at the same time and whatever other information that it uses with the same parent and all that. You could actually create, the hash is consistent. It's recreated every single time. So it's an important point. All right. There we go. If you're not careful, you'll have two commits with the same hash. False. You'd have to be very careful to create that. And I don't believe that's even it's not even like Git is the original blockchain for those that are wondering. All right, you may have noticed that even though you and I, both have the same content in our repositories, we have different hashes. Yes, we already went through all this. Yes, they do. SHA-1, it's beautiful. Which does not affect the hash of a commit. The commit's timestamp, message, author's preferred text editor. Even though it should, I do think all Vim hashes should start with 777, a little bit of luckiness to it. To me, that's the only appropriate thing to do. All right, the plumbing. So far, we've used Git in a porcelain manner. But to sate our insatiable curiosity, sate is a weird word, okay? Lane may have done a little bit of writing for me in this one, just so you know. Let's take a look at the plumbing. All right, it's just files all the way down. All the data in the Git repository is stored directly in the hidden file. You can actually see that. Look at this. If I go like this, if I go find inside the Git folder, you'll notice something right away. Look at this. Look at that thing. That thing looks just like this thing right here, right? 7805.172, 7805.172. Look at that, huh? Kind of crazy, right? That's my commit. Okay, sneaky Git. Very Shakespearean. Yeah, I know, he's very Shakespearean. He uses phrases like upstairs and downstairs, and it's crazy. All right, Git is made up of objects that are stored in the Git objects directory. A commit is just a type of an object. Correct. Use log10 to view your commit hash. Do this inside the object directory, and we already did that. We already saw it. Which matches the format of the file. You'll notice here too. So this is something that you probably don't know about Linux. This right here, this is called an inode busting. Effectively, what inode busting is that a directory can actually end up having too many files in it. If you've ever done it, weird stuff starts happening. So instead, Git, to prevent inode busting, or to prevent inode whatever it is, you'll do this. So this takes the first two letters and then does this, right? I've ran out of inodes before. Yes, I've goofed up myself. So a directory can only be such a large size. So therefore, this just helps separate out things. This is very common. You'll see this in CDNs. CDNs do the exact same thing. The actual naming underneath will start doing weird stuff like this. Screw you, unlinks your list. Yeah, I've done it once. Inode issues are insane, by the way. They're crazy. I ran into this with the massive log directories. Exactly. You have to do inode busting, or else life is painful, and I did it once. And then once you do it once, you never do it. You just never do it again. All right. That's it. That's all there is to it. All right. So that's why they do this. They take the first two, and they turn it into a directory. So that way it just kind of spreads things out. All right, so let's take a look at what's inside this suspicious git commit object file. Have you ever tried catting one of those things? The first thing I ever did when I found out git was just a folder is went right to objects, went right to my commit and tried to cat it out, and it's just this, right? That's a bunch of bullshit right there, okay? What the hell does this even mean? All right. So you can't really do anything. No, it's a mess. Let's see. The contents have been compressed to raw bytes. So that's why git remains small, is because git compresses things. And that's very, very important. All right. The lesson, let's see. Okay, hold on. This lesson's run and submit are a bit different because you need to tell boot.dev CLI where your commit object is located. All right, so we're going to do the exact same thing. So I have to do this, but I have to give it this name, right? Path to file, right? So I'm going to grab this thing, and I'm going to go like this. Let's go git objects 780505 this thing, and then submit. I believe I did that correctly. This one I screwed up last time I tried to do this. Let's see, failed to get this thing. Page not found. Wait, who's he, what's he? All right, let me reread this one. Sorry, sometimes I'm not good at reading lessons, okay? I just want you to know that RTFM, read the friendly manual. Sometimes I don't read the friendly lesson, okay? Let's look at this again. Try to cat the contents of the file. We already did that. Nope, it's a mess. The content has been compressed. We can print it in hexadecimal. I don't really care. This lesson's run and submit are a bit different because you need to tell boot.dev CLI where your commit object is located. Run and submit the test, but provide the path to your commit object file as a second argument. Run lesson ID. Okay, so let's try this again because apparently I'm too stupid. So I need to go boot.dev run lesson ID path to file. Okay. Git objects 78052. There we go. Look at that. I'm getting so much EXP. I'm level 4. You guys wouldn't understand. Practically a Grand Wizard Archmage. I don't think you're supposed to be a Grand Wizard. Right? That's not you don't want to be that. You don't want to be that guy. Okay, I forget. Sometimes I forget things, okay? Luckily, Git has a built-in plumbing command, cat file, that allows us to see the contents of a commit without needing to futz around with the object files directly. So you just use git cat file -p, because technically, like if you're viewing a tree, you have to use a tree command. There's all these different things, but cat file just allows us to look at everything at once without having to worry about its type and all that. So you can just go git cat file this. So if I do this, git cat file this guy, and do 780517, I believe you only need you only need 4 to specify it. You'll notice something. When I cat out my commit, you'll see the author and all this, and then you'll see the message. So it's nice. Then you see this tree command. Look at this tree. This hash, we don't know what this hash is, right? So I can actually go git cat file -p 5b21d. And then you'll notice that it has a blob object, and that blob object is a content. So to kind of put this in perspective, you can think of a tree as a directory, and you can think of a blob as a file. So that's kind of important to know. So when I cat file this thing, you'll notice that it's contents, which is the exact contents of our contents file. They're identical. So do you see what happened there? Why did I capitalize B? For those that don't know why I capitalize B, when I type, I have Dvorak. But even more so when I type numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you'll notice that I typed out symbols, symmetric symbols. It's because I've optimized my keyboard to prevent wrist pain from happening because I program a lot. So I have to hit Shift to type my numbers, right? So sometimes I'll do a capital B when trying to type stuff because I'm still holding Shift. Does that make sense? Okay. There's no reason or rhyme or anything to do with it. It automatically lowercased it for me. It didn't mean anything. All right, so there you go. You can see that. So this is actually really cool what just happened here. Look at this. I was able to cat my commit out, take the root directory tree, cat that out, see the file that was there, then cat that file out and see the contents of that file. This is very important because we'll use it later to grab stuff out. It's kind of fun. It's kind of neat. So there we go. So we can do that. All right, so use cat file to do all this one. Pass an argument to the CLI. Notice that boot.dev CLI test for this lesson take an additional argument to notify this one. Right, there we go. You need to provide the hash. Okay, so I need to provide the hash. There we go. All right, we'll do that. We're gonna grab that bad boy, and I'm gonna go like that, and then I need to grab the. Which hash are we doing that? You need to provide the hash of your last commit. Okay, we need to provide the hash of the last commit. There we go. So I'm gonna go back up here. I think that's all I need to technically do. -S, and then take out this little slash. I think that should do everything I need to do. There we go. Got it. First try. Got it. So good at this. Why would you ever need to do that in Git? You'll see. You don't technically need to do this in Git, but it's really good to understand why. This is where the big eye-opening moment's about to happen for everybody about how Git actually works. Because what we've seen so far is that we've made one commit, right? We've made one commit, and we're going to call it A. And in that commit, we have a tree that's like our root directory. And inside that tree, we have a blob, which happens to be some big long hash, and it is contents.md. All right, this is very important. So this is our commit. This is commit A. So now we're going to add to this, and we're going to see how this changes. All right? All right, I believe I did all this. All right, trees and blobs. Now that we understand some of our plumbing equipment, let's get into the pipes. Here's the terms you need to know. Tree is a way of storing a directory. Blob is a way of storing a file. So you can see right here, I already showed you this. There's the tree. We are able to go through the tree and get all the way to the blob, right? Assignment. Use get cat file again, but this time use it on tree. And you should see a blob with its own hash. Use cat file again on this one, or submit the C's with the blob hash. Okay, we should already be able to do all this because we actually already did this. All right, let's find this little bad boy right here. Where are you? Where are you? Where the hell are you? There it is. Hey. There we go. Bada bing, bada boom. Able to grab all that stuff out. I just grabbed out the file hash because I knew what it was, or the blob hash. All right, second command. A reminder of commands. Git log and cat file. That's what we've been doing. Log is a porcelain command, where cat file is a plumbing command. You'll use log more often when working with the on coding projects, but cat file is useful for understanding Git's internals. We already kind of talked about that. So we're going to create a second file called titles. This is where things get really interesting. Are you ready for this? All right, so we're going to go like this. Titles.md. Paste this all in here, delete that one, run through, and then we need to save, stage, and commit the file, or the files, as long as it starts with the B, right? That's the thing. Git, add this, git commit with the B. There we go. Awesome. And then run the CLI. There we go. I'm going to grab the CLI, and we're going to do this. Bada bing, bada boom. All right, so we've created a second commit, right? This is how you will understand Git. Git stores an entire snapshot of files on a per commit level. This was a surprise to me. I always assumed each commit only stored the changes made in that commit. Now, type 1 in the chat if that's what you thought too. I assume a lot of you thought the exact same thing, that Git stored deltas, right? Yeah, I mean, look at this. A lot of changes in here. And I think that's completely normal. Anyone that doesn't think that Git stored deltas right away, you're lying to yourself. You're like, yeah, I didn't think that. I always knew that it didn't do that. No, you didn't, okay? Your small brain did not think that. We all thought that because that's totally normal thing to think, okay? While it's true that Git stores entire snapshots, it does have some performance optimization so that your Git directory doesn't get too unbearably large. Git compresses and packs files to store them more efficiently. Git deduplicates files that are the same across commits. Now you're probably thinking, isn't that just delta stores? Hold on, let's find out. Let's just find out, okay? Watch this. We're gonna use git cat file, and we're going to find the hash blob of our titles MD, okay? Watch this, all right? So I'm going to go like this. I'm going to go, let's see, I'm going to go git log one line. I'm going to grab this that's my last hash, right? There we go. I'm going to go git cat file. I know there's better ways to find your current hash. Just shut up. This is good enough. This is good for people to understand. Now notice that we have our tree. Also notice we have our parent now. So our parent is our previous commit. So we can actually walk back up the tree if we needed to. This is, if you're wondering how git log works, is that it stores parent pointers as part of the commit. All right? Anyways, so we're going to take our tree and go git cat file -p this. Now notice that there's two blobs. Okay? There's two blobs here. The first blob is the previous contents, and this one is now titles. Okay, so I can actually take this and go git cat file -p, and I can actually cat out the titles file. I can actually go to this one and get cat file -p, and I can cat out this one, and this will give you the contents of that file. But notice this right here. I want you to look at this. Would you look at it for a second? I'm going to jump into my parent, git cat. I'm sure I explained this in a moment in the course, but I like to explain it this way. There's our parent commit. I'm going to grab that tree. Notice that that tree is different than, is a little bit different. Like everything's a little bit different. This is the older version of the tree. Git cat file -p this. Look at contents. Look at contents. It stores a unique tree per commit, but that doesn't mean it stores the entire file. It just stores a pointer to the file. So when I say a commit stores the entire history, it stores every reference. I know, kind of mind blown, right? That's why it's efficient. Because what happens is, you can think of it this way, is that let's say we have commit A, and commit A has the parent tree, and then it has the blob that's pointing to our contents file. Okay, and this is like, let's just say it's like E, F, and then a bunch of letters, right? Blah, 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 blah. Commit B adds that new file, and so it's gonna have that same tree, but this is gonna be a different, notice that the hash is different on this tree, because this tree has a new set of kids. So something has happened to this tree, which means that it can even point to trees that have not changed. That's very important. So we have a new tree. We're just going to call this one 1. We'll call this one 2. And this one is still pointing to that exact same EF, blah, 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 blah. But then we have a new one, which is going to be our titles, which is going to have its, we're going to probably need to call this like titles. And then it's going to have its own commit right here. And so it doesn't update this. This remains the same. So it's very important to understand that. All right, so let's see what we have to do here. All right, we're going to use cat file. We're going to view the hash of the blob for our titles, and you can do that. Save that hash somewhere in your notes. All right, let's save this hash somewhere in the notes because we have to find it. There we go. It's right there. I can just come back to that later. Add a new directory to your project called quotes. Inside, add 2 files. All right, so let's vim, what is it? Did you say quotes? Did you say quotes? I can't remember. Quotes? Yeah, I think so. What was the first one called? starwars.md. And then what was the other one? Dune.md. Dune, by the way, is a great movie. Dune can also fall under the good sci-fi. All right, so there we go. We have those 2 things. Stage and commit both files in a single commit with the message C add quotes. Perfect. Okay, we can do that. Git status, you can see it's right there. Git add this thing. Git commit -m. Put all that in there. Git log, 1 line, should have 3 commits. You can even go like this. Git log -p, which will show the differences. So this first one adds this new file from nothing to quotes Dune, from nothing to quotes Star Wars, and then it doesn't make any other edits, right? And there's the previous commit, which adds titles, and the previous commit before that, which add contents. Okay, cool. Awesome. We got all those things. All right, so we did all that one. Use the command cat file to view the hash of the blob for titles again. You'll notice that it's still the same hash. Correct. There we go, because the file hasn't changed. Run and submit this thing. Perfect. Isn't that cool? Isn't that cool? I think that's pretty cool. I mean, I think that's very, very cool. For me, that was a very mind-blowing moment, is to understand how Git works, because then it no longer felt as confusing. And that was my big kind of like, I don't know, I got really, really confused for quite some time when I first played around with Git because of that thing. All right, what does it mean that files which were once committed, then deleted, will be forever kept by Git? So technically, it's not forever kept by Git. It's forever kept by your history, unless if you prune your history. So you can actually prune your history out of Git, and so that way it would actually clean up any broken references. So it doesn't actually keep, say, deleted commits that don't exist. So git prune -f, yeah. So that will go through. So we will actually do that. I believe in this section, we will actually revive a file that was long lost, or a commit that was long lost. It's kind of obvious that it stores snapshot. Otherwise, you need to walk back the tree a lot for files that don't change often. Yeah, I mean, it's obvious in hindsight, but I think the first time you think and you download, the first time you ever use a version control, you think, wow, how could it possibly ever store everything? It must have to like create the repo by walking all these links. That's why Git's so fast, is it keeps your tree, and then when you need to change your directory, it literally just walks that tree and recreates every single file at each one of those points. Right? But the first time you wouldn't understand that, right? Let's see, 100% of working with Git is checkout, branch, add commit, push, force push, rebase, or merge. Yes, exactly. That's why I say it's not 100%. It's like 99, 95. There's log, there's reflog. Reflog is incredibly important. We're going to go over that. There's also like git checkout. So git checkout theirs versus ours. It's very important when you want to be able to just grab an entire change from one side of a merge conflict. Let's take a command apart. Git config. Okay, so here we go. We're going to actually start talking about config now, because the config is actually useful to use and understand, because sometimes you actually want to be able to change ways in which your Git experience changes, or in which it operates. So let's look at this. All right, so let's take a look at the command. So git config is obviously the top level. It's still the older style command. So instead of git config add, it's git config -- add, which is kind of a pain in the ass. Global is where to store it. So it's either global or local. There's some other places you can store in Git, but nobody actually stores things in Git, right? Or in those ones. At least as far as I can tell, I don't know of any use case where you store it in system. I'm sure there is a use case. I've just never personally ran into it. I've always just used, local or global. All right. So global stored in this right here in your home directory git config, whereas local is stored inside your git configure, right? So if I go like this, if I go in here and I go, let's see, what is it? ls, or find in my git folder, what is it? Name, is it config? I think it's config. There you go. Yeah, there we go. Cat config. It'll say, here's the things that are inside of your local repository. So when it creates a config object, it actually takes your globals, then it takes your locals and kind of combines them one at a time. All right, assignment. You can actually store any old data in your Git configuration. Granted, only certain keys are used by Git, but you can store whatever you want. Yeah, it's just a key value mapping. That's all it is. So you can, I know when I was at Netflix, we actually had a lot of information stored for how we operated over certain stuff. So I used to have a bunch of Netflix stuff on my system at one point. Set the following useless key / value pairs in your local Git configuration. So right here. So we're going to do this for our locals. All right, so it's not too hard. So you can go like this, git config add local. So I want to add a key value and I want to do it locally. And then what do we want? Webflix CEO. Okay, ThePrimeagen. Okay. Actually, yeah, we'll call it ThePrimeagen. And then we'll do the CTO as ThePrimeagen, right? That's the actual CEO of, what's it called? A boot.dev. And then valuation mid. It's a mid. It's a good mid valuation. Hey, who here wouldn't want a good mid valuation? Git has a command to view the contents, right? So if you just go list local, it's going to list everything. You can also just cat it out, right? So as we did earlier, you'll see here's our top level section. Here's our keys and values. So a good thing to notice here is that this is a section and this is a key. So when you look at this, you'll notice that this is the section, this is the key. That's important to know because you can actually delete all configuration by section or by section keys. All right, so there you go. You can list local. So if I just go git config list local, it'll just list all my just local only files right here. All right, so let's grab this thing, jump in here, paste it in. Your company position, mid. Isn't that everybody's company position? By the way, configs were one of the more confusing parts for me. Not confusing by how they operate because they're actually exceptionally simple. But when I first started using Git, config was something that I executed once and then I never looked at again. And then whenever I had to touch it, I was just like, shit, I don't want to do this, right? And then I just got all confused by stuff. And then it felt confusing because I refused to just spend the 3 minutes it took to understand. Set it and forget it, exactly. And then you just don't know how certain things operate, and simply because you didn't learn this really simple thing. This is why I did config, because config is one of those extremely useless things you should pretty much never need to know, but that one little moment you need to know it, it's very useful. It's very, very useful. We've used list to see all the configuration values, but get flag is useful for when you're trying to get a single value, right? So we can do get key. Remember, a key is a section.key name. So username, Webflix CEO, there we go. So we can get the web value. So I can go get let's see, what is it? Webflix.valuation, and it'll go and get mid. Nice, right? Doesn't get config username just get it get config user.name? Yeah, it also gets it. You could get is the default operation, but it's good to know that because you can also do .set. All right, there you go. Beautiful. We did that one. Bada bing, bada boom. All right, this is looking good. All right, the unset flag is used to remove a configuration value. For example, get unset key. Let's remove the CTO. All right, so we'll go like this. Get config unset, right? Everybody loves a good unset, right? I really hate the term unset. Which one are we doing? CTO? Yeah. All right, I just fired lane because you know what? Screw lane. What happened when you tried to unset? Try using unset to remove the section. I forgot to do that one. If you do this, what ends up happening, Key does not contain a section, right? So you need both a section and a value or a key name for this thing to be able to be removable when you use unset. You have to do unset section, if I'm not mistaken. I always forget. The entire section, it failed because you have to use key and value, right? You have to use both. You got to use both. Duplicates. Typically, a key value store like Python dictionary, you aren't allowed to have duplicate keys. Strangely enough, Git does not care. Yes, if you look at my git config global, list global, and then we grep, what is it? Init, you'll notice that I have in here 3 of them. Okay, I had init default branch master, init default branch main, init default branch master. Yeah, it just takes the last one. My bad on that one. Yes, you can. Yes, but if you do that, you have to force push, right? Force pushing is the only way for you to be able to change history for everybody else. And if you do that, you will ruin the whole repo, and everybody will know. All right, duplicates. Unset all. So unset all is if you want to unset an entire thing. You only need a section then, right? Or unset all is if you want to delete a multi-existing key value combo, which is kind of odd having an key set combo. It's just kind of weird. So if I do this and I go like this and I add a bunch of CEOs, I should be able to go in there and go git config list local. And now you'll notice we have a whole bunch of CEOs, right? We have 4 of them, me plus Carson, Warren, and Sarah. All right, so if I want to undo that, I can remove all CEOs by doing unset all, right? Git config unset web flicks.ceo. There we go. CEO has multiple values. Unset all. Bada bing, bada boom. Git list local. All the CEOs are gone. Anyways, okay. So now that we did all this, pretty straightforward, right? Pretty straightforward stuff. There we go. There we go. Awesome. We're kind of getting through these things. The config section. It can be boring, but whatever. It's fun. You just got to learn these things, right? All right, so there you go. So we're gonna do the next thing, which is going to remove an entire section. Now, webflix is a section we have, so if we just go remove section, we can actually remove all of it. So if I go back here and I go, I can add all of this and go git config. If I go git config list local, you'll see that I have a bunch of webflix stuff. So if I go git config, what is it? It's remove section, right? It's not unset section. You know how many times I struggle with remove section versus unset and all of that? Man, whenever I've had to do anything like that, I've screwed it all up. It's so easy. There you go. Make sure I really get it out there. You know what I'm talking about? We want to get it out there. And then also you'll notice that if I go like this, cat config, cat git config, you'll notice that it actually removes the section, right? Just a fun little fact. Fun little fact if you're wondering. You know what I mean? Bless you, my goodness. Yeah, thank you. Yeah, you just edit the file directly. I personally find that I would just rather jump in here and edit this often than doing all that other crap. To be real, it's just much easier because this other thing is just really hard. It's just really, really annoying. All right, locations. There's really only 2 locations that you should really be concerned about. I've actually never used a Worktree specific location or a system location. I've really only done global and local. I find location. Anyways, in my experience, 99% of the time you'll be using global to set things like your username and email. The other 9% of the time you'll be using local to set project-specific configuration. The last 1% of the time you might need to futz around with system and Worktree configuration, but it's extremely rare. Yeah, I've never personally had to do it. I just know that it's been done on my system. So there you go. Here's the set of what's it called, ordering. So if you have a Worktree specific, it's going to be the most specific. Therefore, that's going to be the one that gets presented. Then local, then global, then system. System is like it's kind of like, just think about it like JavaScript and merging arrays, right? System is for all users, correct. Global is not global. It's not a global list, if that makes sense. It's a local global. You know what I mean? It's not a global, it's a local global. All right, suppose you set username to prime at the system level, username lane at the global level, and username TJ at the local level. Which value will you actually get? TJ, even though TJ does stream, but he sucks, okay? Just so you know. Yeah, global's the user. It really should be repo user system. For me, that seems much easier to understand than TJ catching strays. TJ's always catching strays, okay? Shots furried. All right, let's see, which is stored at the home directory? That'd be global. All right, so what is a branch? So now we're gonna get on to branching. So a Git branch allows you to keep track of different changes separately. For example, let's say you have a big web project and you want to experiment with changing the color scheme. Instead of changing the entire project directly as of right now on our master branch, you can create a new branch called color scheme and work on that branch. And when you're done, if you like the changes, you can merge color scheme back into the master branch and keep the changes. If you don't like the changes, you can simply delete color scheme branch and go back to master. So underneath the hood, this is what's actually happening. Look at this beautiful little graphic. Do you like that graphic? It's beautiful, huh? It's beautiful. Does this make sense? So here's a big thing that you need to understand. Tips. Just the tips. The tips is the commit that is the latest one on whatever branch you're looking at. Okay, so you need to know your tips, and then eventually they should merge back at some point, because that's how branches work. They should be branched off of some they call it the merge base. This would be called the merge base. We don't have that as part of this graphic. So this is called the merge base, or the most common ancestor is one right here. And so this is for when you merge, it finds this thing right here and then merges things together. Merge tips, use rebase. Yeah, exactly. So just so you know, these are all commits. Branches, like a branch is literally a pointer to a commit. That's it. Orphaned branches are wild. Yeah, I don't even know how to create, like, honestly, I don't even really know how to create an orphaned branch. It's exceptionally difficult to create an orphaned branch. It's just not something you do, on purpose. All right, so let's see. Because a branch is just a pointer to a commit, they are lightweight and cheap. This is why when people say branches are really cheap, it's because it's just a pointer. That's it. Which branch you're currently running? Git branch. There we go. So I can go like this, Git branch, and you can see I'm currently on master. Fantastic. Remember, you should be on master because we set initial default branch to master at the start of this course. Yeah. So there we go. Fantastic. And we're going to do that, and we're going to execute this thing. Bada bing, bada boom, confetti, feeling good, confettied out of my mind. All right, default branch. We've been using Git's default master branch. Interestingly, GitHub, a website where you can remotely store Git projects, recently changed its default branch to master to main. As a general rule, I recommend using main as your default branch to work if you work primarily with GitHub. Yeah, because if you don't, you have to go in to every single. It's just a pain in the ass, right? That's all it is. If you don't do that, you have to actually go into your projects and you have to set it as whatever other branch you're using as the default, or else it will still use main as the default, and then you will get cloned down a repo, and then main will be like this empty branch, and then you have to undo all of it. There you go. GitLab has main too, and I think newer versions of Git has main as default too. I'm not sure if newer versions of Git has that as default. Like if I go like this, git config, remove section. Don't do that. Unset all. Let's see. What is it? It is a init default branch. There we go. And so if I go git config list, there we go. You'll notice that I still have this one. Did I not do this correct? Is it lower B? Is it really lower B? Is it really lower B branch? Nah, that can't be right? Why are you still here? Why? ¿Por qué? And Maria. Why are you still here? Oh, it's because I'm not doing... gosh, I'm so stupid. Globalist. There we go. I've undid my global list. This is very important to undo your global list. There we go. List. There you go. It's gone. You can see that it's gone. So if I go back here and go like this, make dir testes and cd into testes, we'll go in here and we'll go like this, get init. Using master, the name of this initial branch. This is the default branch name, subject to change. To configure the initial branch name, do this right here, initial branch name. Names commonly chosen instead of master are main, trunk, development. I've seen dev. I like using trunk just to mess with people. Okay. I think it's funny. Your Git might be old. It could be old. I'm on 245. It's pretty new. Git latest version 246. Yeah, I'm only off by a little bit. I using trunk just to feel something. Exactly. There you go. Okay, so now that we're here, there we go. All right, so here we go. All right, how to rename a branch. So you go git branch M for rename, right? Classic M for rename. Am I right? Old name, new name. All right, we're gonna set our initial branch to main, and then we're gonna rename our branch. All right, here we go. Let's just go back in here and git branch M master main, git config add global S. We can actually even do it by the way, you can also do it at a local level. So I can go init default default branch. What the hell is the thing called? It's called main. So there we go. So I can actually do this at a local level. So now only this repo has the default branch as main, whereas all my other ones will still have whatever my global version is. It's very good to know how to use locals and globals. It can be very useful. I've had to do a lot of things where I have to goof around with different versions. All right, there we go. Wasn't it a lowercase b? I think the lowercase b was an accident. I want to say it was an accident. Anyways, there we go. I'm going to copy this one. Oh my gosh. Okay. Dang it. So it's going to, my thing requires me to be a globalist. I'm now a globalist. I am now officially a globalist. Globalism. All right. Really just Alex Jonesing on this thing. All right, there we go. Visualizing branches. Throughout the rest of this course, we'll be visualizing branches. By the way, this is how Git does it as well. So if you do not know, if you go man git commit, I believe they have it in commit. No, Rebase. Yeah, you'll notice that they effectively do this. So I tried to copy a effective version so that way it's easy to understand, easy to see. Okay, sounds good? Yeah. All right, let's see. This means a branch called main with 3 commits. A C is the most recent commit. As you can see, A to B to C, branch. There you go. So this one right here means A, it splits off from A, and there's D and E on something called other branch, and B and C on main. So they are diverging branches with the merge base of A. All right, everyone get that? I'm going to be using that term a lot, merge base. Answer the questions based on the following diagram. Which commits are part of Lane's branch? None, because he's a CEO and doesn't work these days, but it's going to be GH this one. Bam, got it. Man, I'm so good. I'm a globalist. All right, there we go. All right, throughout the rest of this course, I already answered this one. Which are part of the commits of main? It's going to be A, B, C, D. Got it. First try. All right, visualizing branches. Oh, we're doing it again. Dang, we're going to do Prime's branch, huh? Prime's branch is EFA. Or AEF. EFA. Man, I didn't even get close. You should already be on the main branch, your default branch, and you can always check with git branch. I wonder if there's a way to name your default branch something that would break your system. Can you do RMRF? See, 2 ways to create a branch, right? Git branch, new branch name. This creates a branch called new branch. The thing is, I rarely use this command. Yeah, I rarely use this command. Reason being is that whenever I create a branch, I also want to switch to that branch, right? So I typically use git checkout B, just because that, I guess I am a boomer. It's hard for me to break that habit, but the newer ones is git switch C. So I'm trying to show you kids, youngins, to use git switch C. All right, that's the one you want to do. All right, I'm just so used to git checkout B. I can't help it. So if I use git checkout B, sorry, I'm old. My fossils are creaking. You get the idea, okay? So what this does, by the way, whenever you create a branch, it takes your current location, and that's where it points to. All right? So when I do this, my new branch, that will actually create into a new location. It'll have the exact same SHA or the exact same commit. Yeah, it's your head location. So it's good to know that, because a lot of times that's kind of like one of those confusing jumps people have to make. Oh yeah, on itchy. There you go. All right. Anyways, here we go. Create and switch one called add classics. So let's just do that right now. There we go. I've created add classics. Let's see. And then let's see, run git branch to verify. So I can go git branch, and you can see that I'm on add classics, get that. And if I go git log, you'll see that I have A, B, and C. And if I go git log main, you'll see A, B, and C. The same thing. They're the same thing. I believe if I even go like this, find get, what is it? Ref, something like that, right? You can actually see this right here. So you can see it right here. So if I go right here and I go cat that, you'll see it's pointed to this thing. And if I cat main, it's pointed to the same thing. There you go. Makes life easy for you to know these things. Learning Git sucks. Yeah, learning Git, well, it doesn't, it's just time consuming. It's a bunch of little things that you just have to learn. All right, switching branches. We talked about using git switch to change branches. There's another command you'll certainly run into, and it's been around for a long time, and older developers use it, git checkout. Okay, calling us older developers hurts a little bit. Me in the past, git switch is a newer command that is meant to be more intuitive and user-friendly. It probably is more user-friendly because git checkout is kind of like this grab bag, because you can also like check out sides of a merge conflict. There's a lot of weird stuff. Shows the history. Git, okay? Git developers of a certain generation, and that's me also. It's recommended to use git switch over git checkout for simply switching branches. That's what they say. Let's switch to a branch called prime. All right, there we go. The new way, the old way. Right, there you go. For this course, we'll stick with git switch, right? There we go. All right, switch to branch main, run git branch, make sure we're on there, switch back to classics, run this one, run this. Okay, I'm not gonna do that. Yo, dog, I'm happy for you, or congratulations, or I'm sorry. There we go, we passed. I'm not gonna switch around, but you get the idea. It's just git switch without the -C for create. That's all. All right. Up-leveling our abilities. We'll use the add classics branch to add a commit to the project without affecting the main branch. So we're going to actually create the D here. In other words, add classics branch will have all the commits from main plus a new one. All right, so we're going to switch to add classics. We're going to create a new file called classics.csv. And there we go. So I'm going to go vim classics.csv. Go in here. I'm going to yank that bad boy, paste it in here. Of course, the classics. You know, The Princess Bride, I actually watch this every Christmas. It's literally the greatest movie of all time. Here we go. All right, so we have this. We're going to stage and commit the file. The commit message should start with D. All right. Run commit. Okay, here we go. So we're going to do that one. Git add this. Git commit dash D is great. There we go. And you should be able to see the commits with the branch with git log. We don't need to do that. Let's copy that bad boy, paste it in, make it happen. Bam, 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 bam. Got it. We're all in the good stuff. So let's go over here. So we're about ready to start getting into some good stuff. Log flags. As you know, git log shows the history of your commits in your repo. There are a few flags you'd like to know. Short, full, no. I don't really use decorate. Decorate typically works well if you want to see where things are coming from. So you can do git log decorate full if you want to see a bunch of stuff. One line's the one I use a lot. Okay, this is the one I always use because if I go git log, you get like all this crap. But if I go git log one line, you get that. That just feels nicer, right? That's the one I want. What the hell is decorate? Well, this is decorated right now. And the reason why it's decorated, if I'm not mistaken, if I go no pager, no. Okay, there we go. All right, it's not doing it. Effectively decorates default version. I thought there's a way. What's the way? Hold on. Let me go like this. One line T out. There you go. So there you go. That took it off. So if you pipe it to another program, this is kind of like a non-decorated one. A decorated one right here shows where you're pointing at. So head, which is also pointing to add classics, main is on C. That's what decorate does. So git log decorate equals no will not tell you anything about where stuff is at. Does that make sense? And then you can also use git log. Remember how I talked about graph? Graph is pretty cool. Graph one line. So you can kind of see that I'm just going, it's just all one line right now. There's no change right now, but we'll get to the point where we start seeing some changes. Don't worry, we'll see it. We'll see it. There we go. Fantastic. I think that's all I need to do. Run git log with full decoration. We already did all that. Explain the decorations. Let's go. We got it. We got the confetti. We're confettied out of our mind. I'm level 7, by the way. You guys won't even understand what it's like. Git propaganda hour? Absolutely. Kung Fu? No, Git Fu. Remember, Git stores all the information in files in the Git subdirectory at the root of your project. Even information about branches, the heads, or tips of the branches are stored in Git refs heads. If you cat one of the files in that directory, it should be able to see the commit that the hashes points to, which we already did. Use find and cat to find the commit hash of your main branch. We already did that one. What is stored in Git refs head? One file each for a commit. What is in there? I forget. Let's see. It is going to be a Git refs heads is going to be each one of the branch names. One file for each branch containing the commit hash of that branch points to that one. Let's go. Let's go. I'm a genius. Nope, we're not going to watch this. Branching in Git is practically free, and it really is kind of the core operation when using Git. But at some point, you have to get that work from a branch back into the main line. And this is where merging comes into play. Now, a typical workflow for pretty much every dev looks like this. First, we need to update our repository to the latest code. This is typically done through git fetch or git pull. We'll cover those more later. You branch off the main branch and give it a name that kind of represents what you're working on. New feature A. You fix the bug, create the feature, update the docs, and create your one or more commits on that branch. Then finally, you merge those changes back from your branch into the main line. Typically, when you're at a company, this will involve some sort of pull request on GitHub, on Stash, on GitLab, but conceptually, it's no different than executing git merge on the command line. What's the point of having multiple branches, you might ask? They're most often used to safely make changes without affecting your or your team's primary branch. However, once you're happy with your changes, you'll want to merge them back into your main branch so that they make their way into the final product. All right, so here's the visual. Look at this beautiful thing. And then notice this. This right here is called a merge commit. It's very important to understand merge commits, because if you don't understand why Rebase is good. So merge commit, and especially when you look at a log, we'll look at the log here shortly, but it will actually show you why or how these things kind of exist and why they're unique and why it allows for log graph to be very nice. So hold on, let's see what the assignment is just to make sure I don't get ahead of myself. First, switch back to main. Next, our contents file is eerily empty. Yep, update it to contain this. All right, there we go. Now and then we'll content this. Okay, perfect. Let's go. All right, so what we're gonna do is I'm gonna go like this. We're gonna git check out main. Oh wait, no wait. Git switch add classics. Git switch main. Don't use checkout. We don't use checkout. We're not using check it out. We're not doing it. All right, and then update this file right here. Don't you do it. Git status. It's nice. It's not magit. All right, there we go. So commit, let's see, commit the changes with a message starting with E. All right, so let's commit these changes. Git add this, git commit E, let's see, contents, such contents with a new line at the end. Why? I don't know why. There we go. So now we have this one. We have ABCE, ABCE, and ABCD. Awesome. So we should be able to do the whole git log graph all. Look at this nice bad boy. Look at that. Look at how graph does that. It's nicer in one. It's nicer in one line, honestly. One line. You can see right here. So there's add classics. It's been branched off at that point. And here's this guy. So it's a nice way to look at all your stuff. There you go. Why not use checkout? It's just older. Switch is the one, right? All right, there you go. Fantastic, right? So I should be able to just do that. Everything should be good. There we go. Confettied out of my mind. All right, merge commits. We are merging two branches together with diverging history. Look at this thing right here. The diverging history simply means that main branch, the one we branched off of at point A, has commits, and we, some branch, have added more commits. Main has B and C. Our branch, some branch, has D and E. That means when we merge, we need to be able to create a new commit that represents these two diverging histories as one. This is called a merge commit, and it's the only commit with two parents. The process for a merge commit looks like this. First, we need to find the merge base. The merge base, also called the best common ancestor, is the nearest ancestor that is in common to both branches, and in this case, that would be A. We then play main branch's commits into a new commit, and then we play some branch into that same commit. When all the changes are in that new commit, we commit it to main, and in this case, we call it F, and we give it two parents, one parent pointing to C from the main branch and the other parent pointing to E from some branch. If you use git log, you will actually be able to see the diverging from A, the two diverging commits, and then the coming back together in F. Merge commits are the result of just merging two things together. Yep. So what a merge commit does, or how a merge works, is that when you merge in something, it finds the most common ancestor, or the merge base. Then it merges main and this one together to make one super commit, adds that to the front of the branch that you're on, and then has two parents, which is where you came from. Does that make sense? So if we were to merge Vim chats only into main while using this, we would find the merge base, or the best common ancestor, in this case, A, replays those two commits, bam, creates a special commit called a merge commit, and then this thing has two parents. There you go, fantastic, right? So in our current Webflix history, we have this, we have main ABCE, and we have add classics, which is D. So when we merge, we should have this we should have an F commit that's gonna be this little merge branch right here. So let's just do that now. Git merge add classics, I assume that's what we're supposed to do, and we wanted to go F, so that way we can denote it. There we go, we're gonna write that, and we just did it. Perfect, right? So now if I do this whole one-line decorate graph parents business, hell yeah, that's a lot of stuff. You can see right here, classics branched and then came back together. And you can see right here that this is a merge base because it has two parents. Or not a merge base, sorry. Why did I say merge base? It's not, it's a merge commit because it has two parents. Never worked with two parents, children. Yeah, most children in Git do not have two parents. This one does. So there you go. This, you can actually watch it because this one points to this commit. This one points to that commit. They both point to the same merge base. There you go. Now that everybody knows, feels good, right? A lot of Arch users out there confused about merge commits. All right, so logging has to be one of the best tools in the Git belt because Git has extensive logging and observability. If you need to recover work, visually understand how you got to this point, commits along the way, messages that you have created, where the branches and tags are, including in your repository, your remote repository, and of course all the tags that you currently have, and much more, then logging has it. Let's break down a quick command right here. Git log, one line, graph, decorate, parents. Now this looks like a lot of options, but actually it'll make a lot of sense once you understand what those options mean. One line will give you a condensed view of your history. First off, the hashes are shortened to 7 characters, which is the minimum amount Git requires for you to specify a hash. Also, you get the commit message. This gives you a nice quick view so you can see what happened in the past. Graph will draw all the little lines so you can see exactly how your commits have diverged and come back together through merges. Decorate will give you the branch and tag information. This can be nice to see how far you've strayed away from a branch or where a previous branch might be. Parents will give you the parent commit upon every other commit. This can be very nice for merge commits because you can see where the 2 parents came from to create the merge commit. Go ahead, give it a try yourself. Oh, we already did this. I already kind of explained this beautiful niceness right here. Each asterisk represents a commit in the repository. We actually already talked about all this. This is fantastic. Why does the first line show 3 commit hashes? Because it's the first commit in the history? No, because it's a merge commit with 3 parent commits. No, because it's a merge commit. It shows its own hash and the hash of both of its parents. We already talked about that. I think that makes sense, right? Wait, where did my log go? Oh, I didn't print out the log. There you go. You can see these are the commits. Right here. These are the lines. This is its SHA, and then its parent SHA. See, that's parent, 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 its commit SHA. Parent, that's its commit SHA. This is its parent, it's the parent, or the SHA, its parent, the SHA. This is Batman right here. No parents. Beautiful ASCII. Beautiful ASCII. There we go. All right, merge logs. Let's see. You can output your git log, decorate, graph, parents, aside from the hashes, look something like this. We already did this. We just got to answer new questions. Why is the weird diagram, e.g. all these things? Whoopsies, I didn't mean to click that. It's what happens to your brain on Arch Linux after 10 years. That's not what I wanted to do. It demonstrates the branching structure. 3 commits were merged into the main. No, it demonstrates adding classics was merged into main. Boom. That's what it demonstrates. It's beautiful. I want to make sure you guys get it. All right, a fast forward merge. Does everybody, who knows what a fast forward merge is? I'm curious. Type 0 if you don't know what it is. I'm actually curious about this. Well, a lot of zeros. Dang, that's a lot of zeros. I'm shook. I'm shooking right now, okay? The simplest type of merge is a fast forward merge. Let's say we start with this one, main branch, and then delete VS Code. Now, we could run this on main, git merge delete VS Code. Because delete VS Code has all the commits that main has, Git automatically fast forward merges. In other words, the best way, the branch you are merging onto, if the tip of that branch is the merge base, then you can fast forward merge. Does that make sense? Yes. In other words, I tried to, one more time. That's why I've been trying to say the word merge base. Remember, a merge base. So for these 2 commits right here, the merge base is this, right here. So in this example, this one was main, this one was add classics. So the merge base was this right here. So if classics was branched off instead of such contents, the merge base is the tip of the branch you are merging on. Therefore, there's no branch, right? It can just literally update the pointer, the end. Kind of sounds like rebasing main. No, it doesn't sound like rebasing main. That's not what rebasing does. We'll explain what rebasing does in a moment. Rebasing has nothing to do with merge. People sometimes goof that up a little bit. It's not what it does. All right. Because delete VS Code has all the commits that main has, Git automatically does a fast forward merge. It just moves the pointer of the base branch to the tip of the feature branch. That's all it does. Bada bing, bada boom. All right. We'll get to rebase here shortly. So you're just adjusting head pointers. That's pretty much what you're doing. So when you're doing a fast forward merge, main just now points up one, right? Assignment. Because add classics branch has been merged into main, we don't need it anymore. Delete that branch. Okay, we'll delete it. Create a new branch off of main called update titles. Let's see, add a commit to that branch that updates titles MD file and add a curious case of Benjamin Button as the final entry in the list. And then use G. Okay, we got to do a couple things here. Hold on. Let's delete, get a check, not checkout, switch det. See, I always mess that one. Update titles. There we go. Let's just open this up and go add classic contents. What were we doing? Titles? Curious case for Benjamin Button. Is that the one we're doing? Titles MD. We're going to add the curious case of Benjamin Button. There we go. We've added it. So now we have that. And then we're going to just create a commit with G. All right. Git add this. Git commit dash G, a curious case. All right. There we go. Run one line to see what we've done here. Git log one line. You can see right here. Here is update titles. Here's main. Main's one behind. You'll notice that this would be the merge base, right? So main is currently, if I were to merge this onto main would also be the merge base. And that's very, very important to know. All right. So let's go in here. Let's do one of these. There we go. Does all this updating. Bada bing, bada boom. Looking good. Confetti. Let's go. All right, so fast forward. So now what we're going to do is we have this diagram, and now all we need to do is just merge it back on. So we're going to switch to main, and we're going to merge update titles onto it, and you'll see what happens here. So git check out main. Sorry, I did check out, not switch. Git log. You'll see that I don't have G on here. If I go one line, it's probably easier to see. No G. If I go all, you'll see that G does exist only in update titles. There we go. And then we can go like this, graph, and you'll see right here that G is on the end. So it's just straight ahead. So now if I just simply merge, git merge update titles, you'll notice that it does a fast forward merge. And now notice if I go like this, git log one line, notice that this one had a branching factor. This one does not. There's no branch. There's no merge commit. And you can see by me going like this, git parents. So you'll notice that this one is a merge commit because it's merging E44 and 7A0. This one is not because it's just having its parent be one behind. Very important to know. Okay, it's a very important thing to know. People just, they just don't know these things. All right, there we go. Hopefully I did everything correct and I didn't accidentally go forward. Sometimes I go forward too fast and screw everything up. All right, so now we're going to go to Rebase. Everybody thinks Rebase is the most awful thing ever, and it's on Twitter. If I go to Twitter, I guarantee you I search up the word Git Rebase, and there's going to be something awful up at the top. Git Rebase, or hopefully it's going to be me saying people don't understand it. All right, merge. All right, here we go. There you go. Look at that. See? Open Slack. Someone help with Rebase. Branch in Flames. Sends thoughts and prayers. Close the Slack. Go to gym. Rebase. Force push. I fucked up my Git Rebase. Like, look at this. It's an endless supply. Hacker News is having a Git Rebase discourse again. I like this comment a lot. See it? Blah, 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 blah. Again, they hate this one. I think this is the way. Okay. Personal opinion. Rebase is tight. Rebase is the only way to do it. Something about Git Rebase. Thanks, y'all, for coming. I don't even get this one. Okay. I don't even get this one. This one must be Git Rebase. This is Git Rebase, so you got to be careful when you're rebasing, okay? You could screw up the world. I just want you to know that, okay? You could screw up the world. Rebase might just be one of the most misunderstood features of Git. Where the fear typically kind of comes from is that somebody changes the history of a public branch. And when I say public branch, I mean a lot of people rely on this branch for their repos as well. And of course, when they pull and the changes have been somehow altered in the past, all these conflicts and these weird Git errors start happening, and it just causes a disaster for everybody. And then everyone says, Rebase is terrible. I will never use that, only use merge. Well, skill issues. You used it wrong. To understand Rebase, you simply need to understand its primary use case. Rebase helps you to take the diverging commits from one branch and move them to the tip of the base branch that the feature branch is based on. Now that sounds like a mouthful, but it's actually pretty simple. So take this graph right here. We have two branches, main and feature. Feature branches from main at commit A, and main gets B and C added to it, while the feature branch has D and E. Now we want to be able to take the feature branch and get those changes from main. Now with your current knowledge, you would probably merge main into feature, creating a merge commit, and that does have consequences, and we'll discuss more about that in part 2. But for now, let's focus on Rebase. Rebase is going to allow you to move forward feature branch from diverging at point A up to diverging off of point C, allowing for a fast forward merge if you wish to get it back into main. This also allows you to maintain a merge commit free history, and again, there are some consequences for that, and they can be quite nice. And that is it. You'll notice this gives you the opportunity to do a fast forward merge and kind of have a free of merge commit history. This will allow for some advanced Git features to be more easily usable if you maintain this type of workflow. Okay, so Rebase is very, very simple. All Rebase does is update where your branch points to. This is, oh, okay, I mean, technically there's actually a couple different use cases for Rebase, but let's just start here. This is the first one. So pretend we had main and we had feature branch. If we were to get Rebase main on our feature branch, it would take the pointer, which its parent pointer, its merge base is pointing at A, and it's gonna go all the way to C, then replay your commits D and E, and now you have a linear history, which means you can do a fast forward merge. Okay, so it's actually really, really simple. And you'll notice that D and E, even though the commit message is the same, you will now get new commit SHAs. Why would you get a new commit SHA? Well, that's because D, its parent, is no longer A, it's C. So therefore, D has a new SHA. E has a new SHA because D has a new SHA. Now you have to fix all the conflicts. If there was a conflict while rebasing, there would be a conflict while merging. If you're experiencing continual conflicts, it's because you don't know what you're doing. And I will explain why in a little bit, okay? Okay, buddy? Can you calm down? Again, whenever I see somebody say something about all these conflicts and all this stuff with Rebase, what it makes me realize is you don't know what Rebase does and how to get around stuff. So it just moves the merge base. Exactly. It just moves the merge base, and that's really important. Do you talk about conflicts in Git 2? Yes. So Git 1 is all about using Git for yourself. Git 2 is all about using it for a team. So it takes the code from D and E and applies them to code version C? Yes. So literally, the exact operations of Git Rebase does this. So let's say we're on feature branch and we say Git Rebase main. What happens is that we check out main, I'll call that the target branch. We check out target branch. We then take source branch and apply its commits to the tip of target branch. Then we update source branch to point to the new tip. Why is it important to change bases? Reverting. So people really hate git revert. It does make things better when you need to revert. So reverts typically happen in larger companies. If you're just working with like 2 or 3 people, you're probably never going to revert anything, and that's fine. But if you have, say, 100 people working on the same repo, and there is a test that needs to go out that day, and you accidentally screw up main, and you need to unscrew up main, and they can't wait for you to go, okay, this is going to take me a couple days to fix, you have to revert your commit out of the history, and then you have to re-release into production. The reason why that's nice, if you properly do what I consider the best way to use Git, which is to always rebase, right? So here's ABC. You always rebase such that you can do fast forward merges. And whenever you do this, you take this and you merge it into a singular commit, right? You squash it is what's that called, is that if you run into a situation where you need to use revert or revert, I never know how to say the word revert in that kind of tense or in that kind of sense. I always call it revert. I don't know what to do here. Anyways, when you do this, it then is really easy to remove this, right? Always rebase in local branch. I rebase in public. Okay, that's crazy. Don't rebase in public. You can also fast forward merge too. Yeah, just do it with idea. That's not a good way to do things. I'm just throwing it out there, knowing how Git works and setting it up so that it can be very easy to change things. But sometimes I just commit a lot of commits. You should commit early and often. Okay, this is a good way to do things. Committing early and often is great. Do that. But do you lose commit history when squashing? It depends. You lose your history of your local changes, and that's okay. You can do that. You can squash them down to a single one, so that way, when you merge back into the main branch, the public branch, it's just one commit. Now, maybe you want those in 2 commits. If you want them in 2 commits, then squash the commits into the 2 ones that you want. Maybe you want them in all the commits, then keep them all, right? You can kind of choose what you want to do, because when you revert, you can do the same thing as you do in cherry pick and provide a list of SHAs to like take out or put back in. Git Rebase Interactive is the best thing. Git Rebase Interactive is very, very nice, and we'll do that for when we're squashing, right? Why wouldn't you go with Interactive Rebase and squash your commits into a single one instead of merging with a squash? I do that. That's how I do it. So locally, whenever I'm about to do anything, I get all my commits prepared, I rebase, I squash, and I push things up. Try making, yes, we can do this too. This is one good way to do things, but we're going to get to that. That's later on, right? We're trying to stay on task here, okay? A lot of questions. Rebase is always a lot of questions because Rebase gets the biggest bad rap from the internet, and most people have absolutely no gosh dang idea what Rebase does. And so then they're like, oh, but Rebase is bad because it'll screw up your history. And you're like, you're right. You can F yourself up with Rebase. Absolutely. You can chop off your finger with a skill saw. It doesn't mean skill saws are bad. It just means you should probably know how to use a skill saw before you just start slanging that blade all around. Right? I know that's crazy. Both rebase and merge can be used to integrate changes from one branch into another. In some sense, yes. Very, very true. Anyways, all right, rebase versus merge, blah, 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 blah. We're going to do this one. Blank can add additional commit, and blank does not. Merge can add an additional commit. Rebase does not. Correct. So if I'm rebasing and there's never conflicts, can I still lose history from months ago? So I'm not sure what you mean by losing history. People say that because they don't know what it means. What are you attempting to say? If you have history that's in a public branch, you will not change it unless if you interactively squash rebase and then force push, which if you do that, you're a bad person. You should be fired. That's crazy. Don't ever do that. You will actually ruin everybody's life. You actually will. Yes. Conflicts happen whether if there's a conflict while rebasing, there's a conflict while merging. That's a good thing to understand. Nobody wants to see your millions of commits just squash it. Yeah, a lot of people prefer the squash. All right, we need a new branch, feature branch, and to be able to practice our rebase, we want to not include some of the commits in recent main. We're going to use git switch command and create and switch to a new local branch called update Dune, but branch off the D commit. You can supply a commit hash directly in git switch. So we're going to do this right here. We're going to git switch, branch it off of Dune, okay, people? So we're going to go like this, git log one line, and there we go. So D is that bad boy right here. Git switch -c update Dune, and from that one, there we go. I said update done. You get the idea. So if I do that another little one-liner right here, we're going to see this beautiful part right here. If we do one line all, you'll see that head is pointed right here. Update Dune. I'm close enough. It's not my fault I didn't copy pasta. What can you do? Okay, so now that you see that, this is good. This is good stuff. There we go. We're going to paste that in. We should be... Wait, what? Oh, update Dune. Okay, it's actually requiring me to do that. Git branch m update done to update Dune. I don't know why you got to be like that. Git boot dev. Okay, you can't let a man have oopsie daisies here. So you never push until your feature is done, or you need the force push. Yeah, I don't push my features up regularly. I keep them and I commit them and I get everything I want and then I push it up. And then there is a little bit of style points here of how you want to handle things after that. Some people don't like to make changes. In the sense of having to force push again. So all PR changes will become their own commits and then squash that one more time and then merge it when it's ready. That's one way. Or you can merge your PR changes back into a single commit and then you have to force push it. So it's kind of like you got to Riz Git your own way. And some people prefer the PR changes to be their own separate commits. Some people don't. That's the rizzing part, Also, if you have really shitty CI/CD pipelines, you may find yourself constantly, doing that. And Git force push every 5 minutes with amending draft commit. Yeah, that's me called using Git. We've all seen that. We've all seen it where it's just a wall of test. It's just the worst. Yeah, I get a bad feeling when not pushing for several days. Okay, I mean, that's fine. You can have either. No one's telling you not to. It happens. It is kind of weird, right? I feel bad not polling. I like to poll pretty regularly. All right. So now we're going to rebase main. This will do the following. Check out main. Remember, I called that target branch. Replay one commit at a time from JDiesel onto main. Update JDiesel branch support to the latest commit. The rebase does not affect main, while JDiesel has all of its had all the changes from main. There you go. So it's going to pull in those changes. So our assignment. Let's add 2 commits to Dune branch. Add the following quotes to Dune. The spice must flow. And then for that will be H. And this mind killer. All right, let's do this. Okay, Dune is a really good movie. Okay, I don't care what you guys say. All right. Wait. Spice must flow. Okay, good. Git status, so you can see that. Git add this, git commit dash, I think it's H. Spice me daddy, why not? Go into here, that was H. We're gonna do I, grab that one, go back in here, do that, save that, add, git commit. Fear me daddy? I think so. I think that's right. I think we just got it. Okay, so I should be able to git log and see this thing. So there we go. You can see that right here. In fact, I can go like this. Graph would make it nicer. So you can see right now that I've branched off of D. You can see my little branch off of D right here that goes up and does this right here. H and I. There it is, right? So you can see the branch right here. This is the main line. This is the new line that we're doing. What is dash all? It lists every last branch, right? So if you want to list every last branch you can, I believe you can also, forgive me if I get this wrong, I believe I can also go main and update Dune, right? You can also specify which branches you would like to see how they do. What is happening with that here? Let's take a look at that. So you'll notice right here, if you remember, this right here was when we did our merge, our merging and all that fun stuff. Right, so this has update titles and main pointing right here. Do I need I don't think I deleted update titles, did I? Did I forget to delete update titles? Git branch, delete, update titles. Are you sure you want to delete it? Force get the hell out of here. All right. All right. There we go. So you can kind of watch this thing move, right? So there was, remember, we had a split at one point right here that had D and E. So this is the merge commit from D and E. So if I go here, I forgot to do parents. This will make it more clear. So you can see right here, this is the merge commit from, which one is that one? From E and D. That's the one we created earlier. This right here is our current one, update Dune. So you can kind of see each one of the lines forming. And we split off on D right here. So the split went up this way to H and I. So it goes I, H, D, C, B, A for update Dune. And for mainline is going to be G, F, E, D, or actually it's going to be G, F, D, E, C, B, A. I believe that's how that's the ordering. There you go. That's how you read it. You read it from top to bottom, left to right. Classic. Real classic right there. All right, perfect. All right, we're going to do those two things. We have those ones. We're going to run one line. I liked mine where I did run line main. You can see here's a more graphical depiction of it all, right? You can see that. So now our goal here is to rebase it. And so we're going to have, does it tell us to rebase it? I can't tell. Finally, while still on that, we want to rebase our changes. So when we rebase them, you'll notice right now here, let's go back to this thing. You'll notice that we branch off of D for I and H. So when I go like this, git rebase main, and re-execute this, you'll notice it got a lot more simple. We are now right here. It's now branched off of G, which makes it into a nice linear history. All right, we just moved our branch forward. You'll also notice, oh, I didn't save the output, or else you'd see that the stuff all changed. There you go. Pretty straightforward, right? There you go, no conflicts. Why would there be a conflict? We edited different files. So remember, conflicts will happen universally. Since we do not have a conflict in a merge, we're not going to have it in the rebase pretty much either. There might be some edge case where that's not true, but I can't think of why that would ever be true, because a conflict in its core happens because Git has 3 operations: add, delete, modify. And so if 2 operations modify the same line, it can't do It doesn't know how to merge those two things because Git operates on a line-by-line basis. It does not operate within code because once you operate within code, it has to understand the intent of code. And so therefore it can't. So therefore it's going to say, hey, since I can't understand the intent of code, you've modified the same line. You need to do something about it. I don't know how to do something about this. Does that make sense? All right. The advantage of merge is that it preserves the true history of the project. This is true. You know where all the branches happened and where all the merge commits happened. It shows when branches were merged and where. One disadvantage is that it can create a lot of merge commits, which can make history harder to read and understand, which can also make it harder to manipulate history with reverts. And reverts can be a strategy, especially in bigger companies. I had to revert at Netflix probably 10 times in my life. Right? It's real. I've had to do it. Comments can cause conflicts. Don't know about... Oh, comments as in comments in code? Yes. Comments in code, yes. A linear history is generally easier to read, understand, and work with. Some teams enforce the usage of one or the other on their main branch, but generally speaking, you'll be able to do whatever you want with your own branches. It's true. How painful was it? Not painful at all. When it came to that, because I always did the same stuff. I never merge committed. I always did all my stuff really nice and made sure I had a single commit. So whenever I had to revert, which did happen, all I did was just revert commit. Revert commit, walked away. Right? Easy peasy. Right? Warning, you should never rebase a public branch like main. If you do this, you will destroy your life. And what I mean by that is when someone polls, it will say your histories are out of sync. And then you'll have this huge conflict problem. And then you have to effectively undo everything. It's generally good manners to rebase a public branch onto your own personal branch. All right, hold on. Rebase a public branch onto your personal branch. That's kind of a confusing question. I think what it's saying is rebase a public branch and change its history. If that's the case, no, that's bad. There you go. Rebase and git merge are different tools. All right, we already talked about this. It's generally okay to merge changes into your own private branch or to rebase your branch on top of a public branch. Yes, this is correct. All right, undoing changes. One of the major benefits of Git is the ability to undo changes. There are a lot of different ways to do this, but first we'll start by going back a commit history without discarding changes. All right. Well, we have a little story. You guys ready for a little bit of a story? I don't even merge. I just pull. Damn. It's crazy. Why would you do that? Let's see. Okay. The new intern at Webflix tried to add his favorite movie to the titles file, but overwrite the entire file by mistake. To simulate that on Update Dune branch, go ahead and overwrite titles with just one line. The internship. Oh, Vince Vaughn. Oh, Vince Vaughn. All right. I don't know why that happened. I think that's what they're looking for. Oh, he actually doesn't even want that. He wants the entire file overrid. There we go. That's what that means. If you're wondering, this just means redirect output, but it redirects output and destroys the file. Double caret redirects output and appends to the files. All right. Make sure the file is changed by running git status and then commit with -j. All right. Git add this, git commit j interns. Am I right? There we go. Fantastic. Am I right? Am I right? Am I right? All right, git reset is a command that can be used to undo the last commits or any changes in the index. By the way, I use reset quite a bit, okay? Not just soft either, also hard, but soft reset is an amazing thing to use, and it becomes exceptionally good when you screw up a revert, cherry pick, or a rebase. And so it becomes really good, the git reset soft. I know some of you prefer hard, but hard isn't always good. Okay? You can't go hard all the time. You got to go soft sometimes. Trust me on this one. I'll show you. All right. Git reset command can be used to undo the last commits or any changes into to the index, staged but not committed changes, and the work tree, unstaged and not committed changes. So you can do git reset commit hash, or it really shouldn't be commit hash here. This is kind of a oopsie daisies. It should be committish. Committish is a term used by Git to say something that looks like a commit, so it's some sort of hash, or something that can be calculated into a hash. Right? The -- soft option is useful if you want to go back a previous commit but keep all of your changes. Committed changes will be uncommitted and staged, while uncommitted changes will remain staged or unstaged as before. So our current branch is right here. It should be at commit J. Now we should be able to go to commit I by doing a soft reset. So I can go like this, git reset soft. Now, normally it's said to go in here and go git log one line and go and grab I and do this right here and go and git reset I. You don't have to do that. You can also go, if it's directly in history, you can go git reset soft and go head, which is where I'm pointing to, and then the amount of steps you want to go back. So I want to go head, one back. So that's going to be to I. There we go. We did a reset soft to that. If I go like this, git status, you'll see that I have the titles. Git diff staged. You'll see that I've deleted everything for internship. Git diff, you can see there's no changes, no uncommitted changes to the work tree. And if I go git log one line -1, you'll see that I am currently on I. Pretty cool, right? So I undid those changes while maintaining the changes available. If you don't see why this is useful in Rebase, I'll show you later, okay? Don't worry, we'll show you, we'll show you. Yeah, it's good, huh? I personally like that. There we go. J should be gone for the commit log. There we go. We should run this thing. Yes. Yeah, git log, oh my goodness. I showed this earlier. Git log P one line is really nice too. One line -1, because it'll show you the previous changes. So you can see Fear's the Mind Killer. That was definitely I. You can see that right there. I'm more of a mixed kind of guy. Okay. Interesting. I can't really argue that. Can you just keep it? Oh, dang. I was hoping I could get more. Git add -p. Do you use this? No, I never do. I never do patch stuff. I never do any of that interactive adding. Honestly, so this right here, I would definitely use with an editor. It's way nicer. I've never used that. No, I've never used that. Yeah, if you're gonna do patch adding, so git or man git add -p, right? This is interactively choose hunks of the patch. So a hunk, I don't know how they determine the size of a hunk, but hunks is just like somewhat of a change. So long as there's enough lines between two changes, it goes, here you go, here's hunk 1, here's hunk 2. And therefore, you can actually say, I want to add this one, but remove that one. But if we do it with interactive, it actually makes it a lot easier. Here, I'll do it really quickly, okay? I'm going to do it really quickly, okay? There we go. There we go. That's good enough. Let's bring it right up into the middle. I'm going to just go in here. We're going to go in here. I know I'm screwing things up. Who cares? Let's just go like this. Remove me. Right. There we go. I'm going to remove me. So now when I go in here, I can actually go like this. I'm going to add one up to the top and one to the bottom. And when I go in here, you'll notice that there's 2 hunks. Those are hunks right there. So if I were to go git add that -p, you'll notice it's like, hey, do you want to stage this particular hunk? No. I'd much rather personally go in here and go like this. And so I can go, I want to stage that one, and I want to remove this one. Now I only have one change. It's much easier to use a graphical editor for that stuff. Split is useful. Yeah. So anyways, all right, let me just undo that one, and then go in here and go git reset soft. So now here's a problem. Everybody. I goofed up, right? Now I have this commit that isn't quite right and all that. I bet we could find the other commit, couldn't we? Oh, we could, but we're not going to. Git status, there we go. Git diff stage, there you go. You can see all the stuff I've added to it. That's fine. All right, so git hard will undo everything. So git hard will not only undo the changes and move your branch back, it will also clear out your index in your working tree. Assignment, git run status to confirm this one. Run git reset hard to undo the changes. Don't move on before you've done this. Okay, there we go. So I can go like this. Git reset hard, cat titles this. Now you'll notice everything's good. There we go. So I did a reset hard, which will undo the index and the working tree. So, like changes that are unstaged. So that is not, no, because unstaged, yes, it does unstaged, so it just depends. So watch this. So if I go like this, let's go like this. I'm going to add a line, right? Git status. This is an unstaged change to the working tree. Git reset hard, git status. It's gone. Very important. But, so if I get back here, but if I go like this, foo, and I say foo, git status, this is an untracked change. Very, very important. So when I git reset hard, git status, you'll notice that the untracked change, because it hasn't edited my working tree yet, this is an unknown file. It does not get reset hard. Important to understand that. Okay? Important to understand those things. There we go. We did all that. Let's grab that. Let's paste that in. Untracked git's fun with Gitignore. It can be very annoying with Gitignore, yes. There we go. Danger. I want to stress how dangerous this commit or this command can be. If you were to simply delete a committed file, it would be trivially easy to recover because of it is tracked in Git. However, if you use git reset hard to undo committing that file, it would be deleted for good. Yes, you can delete by accident forever. So if you have a change that you never committed, you have an unstaged change hanging out, and you do a git reset hard, you can lose all of it. Very important to be careful about that. So be careful about doing that. Okay? Be careful. Reset to a specific commit. If you want to reset back to a specific commit, you can use git reset hard command to provide that, and you have to provide a hash. This will reset your working directory and index to the state of that commit, and all changes made after that are lost. Okay, so this isn't technically true. This must have escaped my eyeballs. But they're not technically lost forever. You can still recover them via Reflog, or by looking at you can peruse through a lot of the Git stuff, and you can cherry pick back in. This is true, but it can be a bit of a pain in the ass to do that, right? Again, be super careful. In part 2 of the course, we'll cover more advanced stuff. Reflog has saved me many times. It should. Reflog is very, very good. Git reset hard blank undoes the commit changes, deleting the changes forever. Unfortunately, that is not true. I'm not sure how that escaped me. It perceivingly deletes them forever. It removes the changes from your branch and moves your branch head so it appears that they never existed. You can still get them, right? Anyways, I want to stress, let's see, hold on. When provided a hash, git reset hard blank moves your current branch back to an older commit and destructively discards uncommitted changes. Correct. There you go. All right, get remote. Often our frenemies, read coworkers, make code changes that we need to begrudgingly accept into our pristine bug-free repos. This is where distributed in the distributed version control system comes from. We can have remotes, which are just external repos, which mostly the same Git repo history as our local one. All right, that's the nice part. It's a distributed version control system, right? You get the idea. When it comes to Git, the CLI tool, there really isn't a central repo. GitHub is just someone else's repo. Only by convention and convenience have we, as developers, started to use GitHub as a source of truth for our code. So GitHub is just another version of your repo. And that's very important connection to make, because if you don't, you might find yourself fairly confused by a lot of stuff. Let's create a second repo called webflix local, and let's see, as a sibling directory to our original webflix. So we'll do a little cd blah, 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 blah. So I'm going to go make dir back webflix local. There we go. All right, let's see. Run and submit the CLI test from inside this one. Oh, we need to git init to create a new empty repo. All right, let's go like this. Let's cd back webflix local, git init, jump in here, jump over here, paste that in. All right, we're moving fast. Adding a remote. In Git, another repo is called a remote. The standard convention is that when you're treating the remote as the authoritative source of truth, such as GitHub, you would name it origin. There's also some basic rules around origin that can be applied. There's some convenience defaults and all that. By authoritative source of truth, we mean that it's one you and your team treat as the true repo. It's the one that contains the most up-to-date version of the accepted code. Some people call it upstream. Upstream can be kind of unique. If you do your repo, so this depends on your working order. Some people will have upstream in a different fashion. So then origin, if you're working in a bigger team, you'll often find that origin is your fork of the remote, and upstream is the authoritative one. Upstream. There we go. Does that make sense? It's good to kind of know this, and you'll see this often. Origin is typically the one you work with. And so if you're on a small team / working by yourself, you don't need to do this. This would be kind of stupid. You just need this. You don't need to create a bunch of process for no reason, but you do want upstream when there is a lot of people working. That's when it makes sense. Upstream is usually when you're working from a fork in common FOSS. Yes. Yes. There he goes. That on top of branching. Yes, a remote is a repository, right? So we're going to do that right here. So here's the syntax for adding a remote, and it can be a URI. Remember, a URI is very, very important to know that. So what we're going to do is we're going to go like this. Git remote add origin backup webflix. Remember, a remote is just another repo. There's nothing that says it can't be local. Okay? It's good to know that, because sometimes people think remotes are only available like on GitHub. It's not true. It's not true. It's not true. Anyways, oopsies, I accidentally went back. All right, let's go forward. There we go. Let's copy this one. All right, so let's copy this thing. There we go. We have a remote properly set. So we can fetch. Adding a remote to our Git repo does not mean we automatically have all the content. So if I go like this, git log, you'll notice there's nothing here. Nothing ain't there. Fetch brings in all the changes. This is very important. So if I go fetch, it's going to bring in all the changes. This is fantastic, right? So if I go like this, git log, look what happened. Look what happened. Look at it. Would you look at it? Nothing's happened, right? Well, the reason why nothing has happened is because we didn't actually update our stuff. And that's important. It didn't update our branches yet. This is good to know. This is very, very good to know. And so we can also go in our Git objects and we can find things. So I can go like this, Git, I can go find Git. Let's just find and Git. You'll see that up here, you'll see a lot of these things right in here, and you'll be able to recognize some of these. There should be a 78, right? A 78 in here. There you go. There's our first one right there. That's our first commit. That's commit A. If I'm not mistaken, 7805, git cat file dash p 7805. Look at that. Look at that. A. How nice is that, huh? Git fetch money. It's for free. Okay, so there you go. So you can see that we have all of our commits. They're just not integrated yet. So that's important. It's important to understand that happens. There we go. Fantastic. So now we actually need to, we need to do something about it. Now bringing the remote into this, we need to run git fetch. Oh, apparently I did that. Apparently this one is, it didn't actually check to see if I did a fetch first. Easy. I ran ahead. I ran a little too fast, okay? I ran a little too fast. All right, to demonstrate this, run git log, which we already did. We actually already did all that. I'm sorry, I ran so fast. All right. I can't help it. So look at this beautiful thing. We can actually do this right here. You can actually log a remote branch versus the origin. Like, you can see the differences between them as long as we've fetched and did all that. So pretty exciting time. So I can go, so if I go git log, doesn't work, git log main, nothing really in there. If I go origin / main, you'll see all these. Fantastic. Absolutely beautiful. Uh-oh, did I actually screw up our, I think I might have screwed up our stuff. No, I didn't. All right, let's go. Let's go, I'm a genius. I'm an actual genius. All right. All right, merge. We can merge branches with a single local repo. So we can actually merge in the remote branch. Yeah? Yeah, exciting. What music is playing? The music that is playing is going to be bits and something. What is it? Bits and hits, this is Skyrim, but lo-fi. You are a genius? I'm not sure about that. Okay. Can you explain the difference between branches and upstream / origins? Remotes. So the second part of your question are called remotes. Remotes. Oh, this guy's being really annoying here. Hold on. There you go. You're banned forever from YouTube. I don't know how to undo it, so if I don't click this button, it's done. It's forever. Dang, it literally just left. Sucks to suck. All right. These are called origins, or not origins. These are called remotes. Now, remotes are just repos. Branches, well, they're branches. They're just pointers to commits within a repo. And so there's a big difference there. So a repo can contain many branches, and they don't have to be the same set of branches. Branches are just pointers to commits. Does that make sense? So again, a remote would be, or a repo is just a collection of commits. A branch is just a pointer to a commit. It's a mutable pointer to a commit. A tag is a non-mutable pointer to a commit. It took me a couple times to get that right. GitHub is just one large Git repo. That's all it really is. it really is just one large Git repo. They do a lot of really crazy things. So, all right, so now let's merge this stuff in. So I'm gonna go like this, git merge origin main. So I'm gonna merge the main origin into my origin right here. So if I go git log now, you'll see all the beautiful stuff. This curious case of Benjamin Button, everything's looking real nice. Fantastic. So I'm gonna go like that, I'm gonna grab that, we're gonna grab this bad boy, and confetti time. Yes, there is no, so this idea of local and remote, it's remember, Git is a distributed version control. One repo is not somehow the authoritative source, and another repo the downstream source. Every repo is its own repo running, and you're syncing between them. So you can actually have many authoritative repos. It's just typically to make life super easy, you have one, which is GitHub, and then you pull and push to that so everybody can pull and push to the same thing. Does that make sense? There we go. All right, GitHub, blah, 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 blah. So remember, Git is not GitHub. GitHub is a product by Microsoft. Git is a source control. GitHub is a way for Microsoft to make money and to scrape your data and to collect it all for the AI, in which it's attempting to create junior engineers that cost less but still cost a lot, and then to use that to get companies to pay them. Yeah? Okay. Now that we understand what GitHub's purpose is, which is to steal your data, that's why they give you free repos. Now, let's look at this. All right, AI alert. Yeah. Create a GitHub account. We already did this one. Assignment. All right, run all checks. Ensure that your GitHub user exists and is authenticated. There we go. I already have it authenticated and all that fun stuff. So there we go. All right. GitHub repo. Just like we created a Webflix local repo and use a Webflix as a remote, GitHub makes it easy to create remotes that are hosted on their site. All right, perfect. We can create a new repo. So hold on, before we do that, I got to go like this. GitHub, ThePrimeagen, Webflix. I believe it should be there. Or did I name it something else? I didn't name it anything. So what I'm going to do here, settings. Let me go all the way down to the bippity bottom. Delete this suppository. I want to delete it. I have read the instructions. ThePrimeagen / Webflix. There we go. Delete this one. Holy cow! I'm gonna need to do. I'm gonna need to give a stool sample after this to really get everything done. Whoopsie daisies, wrong thing. There we go. Do that thing. All right, assignment. So I may have to darken my screen for this because I don't know if I have to type in stuff. Create a new repository on GitHub called this. Okay, let's do that right now. Go on here. Actually, I can just go right here. Create new repository. Let's call it Webflix. There we go. Select owner. ThePrimeagen. There we go. Create. Go in here. We have a new remote right there. Fantastic. Looking good. Oh no, we have too many tabs open. All right, authenticate your local Git configuration with your GitHub account. I recommend installing the GitHub CLI with one quick installation. I already have that. GH authorization, and then do that one. Let's see, which one are we doing that in? Let's see. Add a remote in your Webflix repo. There it points to that one. Okay, so that's Webflix. Git remote add origin for Webflix, which is right here. There we go. Be sure to place your username and do git ls remote to make sure it's all done correctly. Git ls remote. There we go. I just have that bad boy right there. Do I need to push up my changes? I don't think I need to push up my changes. It doesn't seem like I have to push up my changes, but we'll find out. Yay, I don't have to push up my changes. All right. So there we go. Git push origin main. All this does is pushes up your branches changes to the remotes, right? So I can actually, so with Webflix local, I can actually push into Webflix. And so therefore from Webflix, I can push into the remote. So here, just to show you that, I go like this, git branch, git switch, we'll call it foo, and go git push origin foo. There we go. So if I go back to this guy, I can go git branch, and you'll notice foo's now there. Foo was just pushed up from one remote into the next. That's all we're doing, is I'm pushing it to a repo. And you can put permissions and all that on what can be done and blah, 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 blah. That's what it does. So there you go. GitHub is not like that crazy complicated in that sense. It's just Git. The crazy part about GitHub is all the managing and making it scale and all that other stuff. Git branch dfoo. There we go. All right. All right, what do we got to do here? Do I got to push up all my stuff? Yeah. Git push origin main. There we go. I push my main, throw that in there, run all checks, confettied out of my mind. There we go. Have we gotten to rebasing yet? We went past the basic rebasing. Yeah. Let's see, pull. Fetching is nice, but most of the time we actually want the file changes. Yeah, there we go. So we can go pull remote branch. We already did that in Webflix. And so if we were to do this again, we'd be able to do it from, up from the remote. Let's use GitHub UI to commit a change to our repo and then pull it down. Navigate to GitHub, navigate to classics, edit this file, add a new line. All right. So we're going to do this right here. Watch this one. This is going to be a little bit wild. We're going to navigate to classics. We're going to edit this one by hand. We're going to throw that in right there. We're going to commit changes. And how do we want to commit these changes? I want to make sure I have the correct name just in case. To pull the, let's see, hold on. Commit the changes, but add the message J, update to classic Vs. Okay, there we go. J, commit changes. Boom, committed. Out of my mind. All right. Let's go. Commit the change using the UI. Okay, we did that. On your command line, make sure you're on branch main. Merge the changes from update Dune. Okay, so git check out main, git merge update Dune. There we go. Git run git pull origin, which will pull in the most recent command. All right, git pull origin main. There it goes. It pulled it in. Oh no, I have diverging branches. Por qué, Maria? I'm not supposed to have merging branches yet. This is not supposed to happen. Oh my gosh, I have diverging branches. I was messing around too much, and now look at me. Now look at me. I'm 4'20", exactly. This is where I give up. It's not that bad. All right, so this isn't too bad. So, you should also do this. Oh, did I do that? Let's see. If you get diverging branches, run git config pull rebase false. Make sure git will merge on pull and try again. So git status. So there we go. So if I go like this, git config list grep rebase. Do I not have it? Weird. I thought I did. Did I not have that on? Git config add local rebase. What is it? Is it pull rebase? Pull rebase false. It's like I pre-planned for this. There we go. Beautiful, right? Beautiful. Can we agree with that? I did do it. I actually probably deleted it by accident. There we go. Now I have a nice merge. Now I have a merge commit, which we, geez. And so we got a merge commit with a K. There we go. There we go. We did all that one. Make sure everything worked with git log one line. Git log one line. There we go. A, B, C, D, E, F, G, H, I, J, K. There we go. There's my main right there. Isn't that nice? Little annotations, by the way. Origin. That's where my origin's at, or at least where I think my origin's at. This is where I'm at. This is where my update Dune at. There we go. Perfect. First commit was, in fact, not Batman. Pretty poor move on my behalf, honestly, not naming my first commit Batman. It's really the way you got to do it. Oopsies, I forgot to do this. Assignment, switch to a new branch called add classics. My bad. Add another line, this one. Okay, will do. Git switch C, add classics. This stuff is kind of easy. I don't think there's anything very interesting here that's going on. That's why we're kind of just moving rather quickly. We're going to do a pull request. If you've never done a pull request, they're really not. They're not hard at all. They're very, very simple. Oh, my eyeballs. There we go. By the way, was I supposed to... No, I don't think I was. Anyways, I just want to make sure I didn't goof up anything. All right, there we go. So we're going to do this thing. We're going to add the classics. Let's see. Classics. There we go. Alfred Hitchcock. Hitchcock. Get status. Have the classics. What do we want to call this thing? This is an L. We're going to take the L. Git add this. Git commit. Sorry, this part, I mean, maybe some people are, find this stuff. They don't know how this stuff works. To me, it's very, very boring, right? If you haven't done any of this stuff, it's very, very simple. And you're going to do this. Can you do a pull request directly in Git? Well, pull requests are something of GitHub's more nature. So we're going to be doing a pull request. You can use the GitHub tools. You can't do it directly from that because Git does not know about GitHub, if that makes sense. All right, so there we go. We did all that. And so now I just simply need to push the new branch up to GitHub, navigate to GitHub, do a pull request, click new pull request, set the base branch to this one, add classics. We want to merge this one, create the pull request, but don't merge it yet. There we go. Very, very simple. So jump in here, git push origin, add classics. Notice that I do git push remote branch. You don't technically have to do that if you set up tracking. Alfred Hitchcock. Interesting. Compare. There we go. Add classics. Classics goes into main. Create pull request. Bada bing, bada boom. Look at this beauty right here. You can see these two things because we're not quite up to date with all the stuff. I'm not reading chat. Chat is unhinged today. Absolutely unhinged. All right, there we go. Run all checks. Looking good. Absolutely unhinged. All right, my workflow. Well, on this topic of pull requests, I want to share my 90% of the time. Let's see. I keep all my serious projects on GitHub. That way, if my computer explodes, I have a backup. And if I'm ever on another computer, I can just clone the repo. This is true. I configured my Git to Rebase by default. That's why we had that. That's what I do rather than merge. So I keep a linear history. Right? I like the linear history because I just part of what I've always done is I always have this as true. It's just, it's hard for me not to. Git config. Let's see. Local. Unset local, what is it? It's poll.rebase. There we go. This is what I do. I just do this. I do very simple stuff when I'm working by myself. I just add my changes and push it up. I think when you're working by yourself, you don't need to practice all the greatest things because it doesn't really matter, right? When I do my team workflow, I go on here and I do the add and I make sure I rebase everything and I make sure it's all the ways exactly the way I want it to be. And I do all that and then I do the merging. Is it a good practice to add it to the global? I add it to local because I wanted local behavior here. I don't like to do things on the global scope if it's something I don't want done for everything. Since I wanted to turn off Rebase, I didn't want to put it globally on in case I forgot to turn it off, right? So if I go git config, global list, we're a damn global list. There we go. Re-enabled. See, I got to turn that off. See, I don't even have it up on here. See, I must have deleted it on accident. Git config, add global poll rebase. Rebase. True. There we go. Push on save, of course. Yeah. It's one of those things that's really hard to remember. It's why I try to do, whenever I'm doing things like this, I do it to the local as opposed to the global because I always end up effing stuff up. Just like that. I take off all these things and I forget to add stuff. Delete my feature branch, repeat. Yep, there you go. So you know that. When working solo, do I use many different branches in pull request workflow? No, I don't. I think it's a waste of time. Personally, I think it's a huge waste of time. My workflow, while on the topic of pull requests, I want to share, I did this. All right, when working with the team, yeehaw, force push, no. Work on a branch, feature branch, then open a pull request for review. That's how I do it. It just makes sense. Right. So if you ever want to commit to open source, you obviously need the fork. You need to create a pull request. You need to do all that stuff, right? Gitignore is really, 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 really important because obviously node modules, if you don't know about them, they're horrible. So you need to git add commit some message here, git push origin. Problems will arise. Gitignore file just simply allows you to say, here's a specific file or a class of files to ignore. You can also go with the inverse, which is you can ignore every file and then just add the files you want to have. It's kind of like a fun way to do stuff. If you've never done that kind of stuff, right? And so you could have, is this the first or second? This is the first part. So we're going to create a node of modules, or we're going to create a gitignore file that has node modules in it, right? So if I go like this, vim gitignore. Oopsies, I already have vim open here. Whoopsies, we don't want to do that. I want a gitignore and go node modules. By doing this, if I go like this, make dir foo, and then I go back to here. Let's see, and I go back in here, and I go in here and go like this, bar.md, save that, and then I go one more and go node modules, and I go in here and add foo.md, right? Bam. If I go git status, you'll notice something. Foo hasn't been added yet, right? So it doesn't have any idea what's underneath. So when I go git add everything and do this, you'll notice that it only adds foobar. It does not add node modules, and that's very important. And that's because this matched anything. It's just a match. So you got to be careful. Careful. Include bid and build, you coward. No. Another cool thing about Git, I'm not sure if I talk about this. Here, I'm gonna go in here and I'm gonna erase that, right? I'm gonna erase that, git add this, git status. You'll now notice node modules is now added, right? Awesome. So that means here's an interesting thing I can do. I can go in here and go Gitignore. You can do, let's see, let's go bar. Anything with the word bar in it. Git status. Now you'll notice we have this. And it didn't really quite do it. I believe I had to go MD exact match. Can I exact match it? Git add this, git status. I think because I already added it, it causes a weirdness. Git restore, staged, foo, bar.md, git status. There we go. It's gone, right? It doesn't exist. It's already been staged, so I had to unstage it. There we go. So if I erase this and go back here, git status, you'll notice that it's now able to be added back. So you can actually do inner directory git ignoring, which is pretty nice. I'm a big fan of that. If you want to do it. You don't have to do it, but it's cool. It's cool to know that it's possible. And one last thing that you can do as well is there's a file called what's it called? Git info exclude. You can see it right here. There's the path. Things that are ignored in here are ignored for your local repo. They're not ignored for everybody. And so this is a really cool little file right here if you don't know about it. I'm not sure if I talk about it, but you should. Like say you, like for me, one thing I always do is I go like this. I always have like an out file that I always have. So instead of adding it to my Gitignore, I can just add it to my excludes. And by adding it to my excludes, when I go, when I run some sort of program, echo foo, and pipe it to my out file, when I go git status, my out file just doesn't show up. But nobody else has to know about my outs ignore. I like keeping all the ignores in one place. It doesn't make sense if you're working on a team, right? When you're working on a team, I have a bunch of stupid files that I create regularly, out2, and so I don't want to have out files inside the Gitignore. So I put it inside the git excludes list, which is kind of like that special one. There's also a home Gitignore. I didn't know about the home Gitignore. Is this like one? Is this a global project ignore? See, I mean, Git has a lot of features, so I didn't know that. This is the same as a global level Gitignore of your work. Oh, cool. All right, perfect. All right, so here we go. Assignment: create 2 files in your repo. Secure passwords.txt and create a let's see. First, create this thing. All right, and create that. All right, we're gonna do that, and then guilty pleasures. All right, perfect. Git check out main. I assume we're supposed to be on the main branch. Are we on the main branch? Yeah. Git status. rmrf foo. Let's get rid of all this. Git status. All right, git add this. Git status. There we go. Oopsies. What is it called? Webflix. There we go. I'm gonna get rid of that thing. Gitignore and go in here. Oh, that's not what we wanted in there. We wanted it in secure. And then what did he say? Passwords.txt or some crap like that. And is that what he wanted? Password.txt, yeah, and then one called guilty pleasures. All right. Guilty pleasures.md. Boom. The notebook. Let's go. Guilty AF. Finally create a Gitignore with both, ensure both of those files are ignored. Ignore the entire secure directory, and then, all right, perfect. Secure, and then guilty pleasures. All right, and then let's see, with the message starting with M. All right, git commit. We got to do a little M message. Git ignore my notebook pleasures. Okay, you don't know. You just don't even know how good the notebook is. All right. There we go. Nested git ignores. Oh, I actually already went through this. We actually talked about this exact thing, didn't we? Oh my goodness, we already did this. All right, which is ignored. All right, hold on. What are we doing here? Here's the let's see. Here's the contents. All right, we have these contents. Here's the contents, which is this source assets git ignore, which is going to be only devs and main.py, and this one's going to be bin activate. So that one's going to be this one right here, and this one's going to be only dev, and what's the other one? Main.py and main.py. Okay. Here's the contents. Wait, hold on. What's the question? Which is ignored? They're all ignored. Aren't they all ignored? Aren't they all ignored? Does not necessarily have to be at the root. It's fairly common to have this one. Am I misreading things? I mean, this one will be ignored. Yeah. This one should be ignored. And this one should be ignored. Okay. Oh, yeah, of course not. I'm so stupid. Okay, sorry, I'm so stupid. This one's main pie, which does not exist at this level. I wrote this. I actually wrote this. This one won't be, and then the root one has venv, bin activate, which this one should be ignored as well, right? Am I wrong here? Shouldn't that one be ignored just equally? Whatever. There we go. Only devs. I want a main cupcake. You can't have one. Wrong. What am I missing there? Sell boozled? Yeah. It's not one of the options. Oh. Let's see. Activate is a shell script, not a folder. Venv is in source. Oh, Venv is in source. My bad. Okay. I just wasn't looking hard enough. Okay, your Gitignore file does not necessarily need to be at the root of your project. I haven't looked at this in a little bit, okay? I wrote that to try to be clear. It's fairly common to have multiple Gitignore files. Yep. There you go. We've already talked about this one. Here's let's see. We have already done this one, which is not ignored. Okay, so source, venv, bin, this one. Okay, this makes sense. Now we got it. Test.py, which one? Let's see. Test.py. That one's not even in there. There we go. We got it. Skill issues. I'm skill issuing. Come on, shut up. It would be rough if Gitignore only accepted exact file path sections. Luckily, they don't. Let's go over some wildcard common patterns. Dude, the star, that's the one. That's the one that always works. I do that constantly. Root patterns, patterns starting with the slash are anchored to the directory containing the Gitignore file. For example, we ignored main pie in the root directory, but not any subdirectories with that. Negotiation or negation, you can even negate patterns with prefixing with an exclamation mark. This is useful if you want to ignore an entire directory except, say, an example file. I find that to be really, really useful, is that kind of move right there. I really do like that. You can do comments. That's just like typical shell comments. But how do you make use of multiple Gitignores? Save some notes or something. If you just want something ignored a certain way, you can do that. I found it really useful when it came to mono repos. So if you've ever done mono repos in with like Node or something, you want to be able to have a Gitignore for each one of those repos. It seems to be really nice that way. So yeah, data directories, yeah, exactly. You just have like these little Gitignores, so that way you don't have one giant Gitignore that's super hard to figure out what the hell is happening. Instead, you can just do that. So it's nice. All right, assignment. Use this Gitignore file to answer the question. All right, so that's a comment. We're going to ignore everything with a text file except for the ones with name, and then we're going to do source main and then content. Source content is ignored. So this one is ignored, source content MD, because this one is an exact file name that matches this one, and it's not anchored. So it should be is ignored. Let's go. Patterns. Yes, we already talked about patterns. We already did all this. What's the other question? All right. Main.js. Is main.js ignored? No, it's not, because that's a comment. It is not ignored. Let's go. Nice try trying to bamboozle my own questions. All right, here we go. They're trying to bamboozle me. All right. Assignment. Part 2. We'll do that soon. All right, here we go. Let's ignore a generated file. We ignore generated files because they can easily be regenerated from stuff we do track. In this case, we're going to use pandoc to generate HTML from markdown files. We'll ignore the HTML files, but commit a markdown file. First, install pandoc. Brew install. I don't have that, but we do have this guy. I can't show you guys this screen. All right, here we go. There we go. Look at that. Look at how good that is. Look at how good that is. Fantastic. There we go. We installed pandoc. We can run pandoc version to see what that is. So I can go like this. Pan up hash r pandoc. My password is big boobs. Everyone knows that. Big boobs 69420. All right, here we go. Running pandoc. All right, create a new file at the root directory called advert.md with the following content. All right, so let's do advert that one while supplies last. There we go. Vim add. Let's go to this one. Vim advert.md. Paste all this stuff in. There we go. And then run the markdown. Let's see. Run the following command to generate the HTML document from that. There we go. Pandoc. Bop bop bop. Get status. So now we have this one, advert HTML. Beautiful. For fun, open up the Markdown HTML and see what. Let's see. We can do that. XD. I don't want to do that. We don't want to do that because I have to go like. I don't even think XDG open. Does that work on? Look at that. Look at that beauty. Look at that beaut. Would you look at it? Would you look at it? There we go. We're gonna do a Gitignore. I think I have to do a Gitignore here. Oh, it doesn't technically say. So finally add the file. Oh, to the Gitignore. There we go. Vim Gitignore. What is it called? It's advert.html. Bam. Get status up. Get status. So I think I should be able to do that. Nope. Do I have to add stuff? Finally, add the Gitignore. Oh, and commit the change starting with n. Git add, git status, git add, git commit n. Was it n? Yeah. Foo bar. Screw it. Got him. There we go. I finished it. We finished the entire course. Just like that. I'm level 12. You wouldn't even understand what level 12 is. You wouldn't even understand it. What's your opinion on how organizations should handle PR merges into main? Squash, merge commit, or rebase? Which is most useful when you are responding to an incident? Which is the most useful for dev happiness overall in a prod environment? I mean, here we go again. I know. Here we go again. Damn. I'm gonna say it this way. I personally like to rebase and squash. I like fast forward merges. I like to be prepared for the eventuality I need to revert changes. That's it. Now, some people, it depends on your size. Honestly, if you have just a couple people, like, why even have a policy? I want to be real out there. Why even have a policy at all? Some people like to rebase. Some people like to merge. Screw it. Let it all happen. Do you really want to set up a whole bunch of red tape for you and one other person? Like, why add more shit to your life? Here, I'm going to throw something out here. No matter what you choose, merge chaos, fast forward merges only, rebase squash, no matter what you choose, there will be a group of people that complain about it. So we're going to start this one. So this one is a little bit different, okay? This one is a bit different. This one's going to go over a bunch of like conflicts and stuff, okay? Hey, I know you're about to take Learn Git 2, and I really wanted to show you a couple quick techniques to make it a little bit easier because inevitably you may mess up. At least some of you are guaranteed to mess up. You didn't read the instructions well. Maybe it's not quite as clear as it needs to be. And so these are two little commands that are going to help you a whole bunch. So the first thing I'm going to do is I'm just going to show the contents of the previous commit. That's going to show foo with a message of foo3. Now, every now and then you may have goofed up a little bit with your commit message and you just want to change it. You can go git commit amend. This will give you a chance to change your message, but as a warning, it does change your SHA. So obviously this is a destructive history altering item. It allows you to change the last commit message. So if I go like this, git log one more time, you'll see now it's foo4, and you can see that. And if I go git foo, let's see, if I do two of these, you'll notice that there's not a foo3 in here anymore. Looking at the change, you'll see that all it is a new file called foo. Previous file was dev null, meaning there was no other file. So it's just a new file called foo with a single line called foo. Now, if I actually want to undo this commit completely, I can go git reset soft head tilde1. This will undo that commit. So now if I go git log just one line, you'll notice it's not that anymore. But because it's soft and it leaves changes in your index and work tree, if I go git status, you'll see right away, new file foo. Okay, we can work with this. Git reset hard would not only undo that commit by one, it would also remove the file. So if you ever have to say change something within a file, or you need to change the commit message, consider git commit amend, or consider git reset soft. Now I use actually git reset soft quite a bit when I'm doing a rebase merge conflict. This does happen every now and then where I'm rebasing and I go, okay, I fix all my changes, and then I actually git commit those changes as opposed to calling git rebase continue. If you make that mistake, you can actually use git reset soft head tilde1 to undo that commit and then rebase continue. It's kind of like a, it's a lot of IQ, and it's really, really nice. So I just wanted to give you those 2 tips because honestly, this course can be a bit meaty, and without these 2 things kind of fresh in your mind, you might accidentally find that you get yourself into a bad state and it's hard to undo. It's actually pretty easy to undo these bad states. The name is the Gitignore. All right, here we go. Let's do this. Let's get going. Okay. Welcome to Git Part 2. I wrote this also, where you learn how to use Git with a team. If you haven't taken the first Git course, I'd recommend starting with it because it contains all these basic operations, okay? The stuff in this course is great. Let's see, the stuff in the first course is great if you work by yourself, but you'll need more if you want to stand a chance as a developer at Megacorp, where we sell synergistic CRM, customer relationship management solutions to enterprise. That's right, we do. Hey, look, I'm wearing the same shirt. What are the chances? This course assumes you've completed number 1, so you'll have all this crap that we've already done. We have already blah, 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 so we've already done that thing. Same shirt. What are the chances? There we go. I'm just going to run this because we've already done this, okay? We've run it. We've done it. You need your own fork of Megacorp's starting repo. A fork is a copy of this one, so we need to go here. I'm going to first need to jump in here. I'm probably going to need to... can I fork? Or is it not going to allow me? I can't tell if it's going to allow me or not. Nice. Let's go. I've done it. Please select owner. Our fork already exists. Shoot. Okay. It's case sensitive. Today I learned it's case sensitive. There we go. I thought I just deleted that, but apparently I didn't delete that. There we go. And create. All right, we got the fork. We're forked out of our mind. All right. Let's do this. Let's do this. All right, so we got a fork. We did that. We pressed the fork button. We did. Hey, look at that. Hey, look, that's me. Hey, that's me doing that. All right, boom, 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 boom. Run, check, paste in your link. We're going to paste that link. All right. There we go. All right, what is a fork? We created a fork of the official Megacorp repo inside your GitHub account. It's a copy of the original that you can modify without affecting the original. You may have noticed that there is no manual entry for Git fork. Git fork is not a real thing, right? Why? Forking is not a Git operation, but it's a feature offered by many Git hosting services such as GitHub, GitLab, and Bitbucket. Those services fork a repo by creating a new copy of the repo and associating it as a fork of the original. There's something called like a fork network or something like that with GitHub, which is very confusing. It's like one super repo, and there's some sort of thing that they do underneath that's a little bit more confusing. This is gamified Git tutorial. This is a Git tutorial I wrote and I'm going through. When you fork someone else's repo on GitHub, you simply clone their repo into your local machine. You create a new branch of the originals. Well, technically, I think it has something to do with this in the fork creation network, but I don't really know how it works. Create a copy of your own, let's see, of the repo in your own GitHub account. Boom, let's go. That's what we did. All right. I'm not working TC? Nope, okay. Git fork is a command line operation that takes no false. All right. Now let's clone it down. Let's clone Megacorp. RM, RF. Let's get rid of Webflix. Let's get rid of Webflix local. Let's get rid of Megacorp. Git clone. ThePrimeagen. Git clone. Primeagen. Megacorp. Vim. We're in. There we go. Perfect. All right. We're in. Okay, so let's start doing this whole thing because this is the one that involves a bunch more stuff. When you fork someone's a repository like a platform like GitHub, you can copy a repository into your account. This is the standard way to contribute to someone else's open source project. Steps are typically fork the repo into your account, clone the fork to your local machine, create a branch or feature, make the changes, commit the changes, create a pull request. Bada bing, bada boom. You're probably asking yourself, why should I fork a repo instead of cloning it? Cloning is a lot easier. Well, that's a good question. You first have to answer the question, am I interested in contributing back to the main line, or do I just want to peruse the repo? If you wish to just simply peruse the repo, then a clone is just fine, whereas if you wish to contribute to the open source project, then it does require a fork. Here's usually my workflow when it comes to forking and making changes. 1, I just fork the repo. 2, I will clone down my forked repo. 3, I'm gonna make the changes to my main branch. 4, I'm going to push my changes up to my fork's main branch. 5, I'm going to open up a PR with my changes from my fork onto the original repo, along with a nice detailed explanation of what I have changed and why. And finally, I get rejected, go home, cry a little bit, skill issues, but nonetheless, I tried. And that's what really counts, doesn't it? It's also worth noting that whenever I clone down my fork, I also add a second remote that I call upstream that points to the original repo. And the reason is that when the original repo changes, I can bring in their changes. And that way, when I fix something, I know that I'm fixing on the latest version. I'm not accidentally fixing something somebody else has already fixed. This also avoids having conflicts during PRs. And if you wish for your PR not to be rejected, here's some pretty helpful hints. Number 1, whenever I make a PR, before I hit that button and say, make it live to everybody, I review my code on GitHub. This weird thing happens to me. Whenever I review code on GitHub, I seem to catch things that I don't catch when I'm in my own environment. I kind of think of this as editor blindness. You're so used to everything that when you see it in a concise, different way, you just see mistakes you've made so much easier. Probably most importantly is make sure the maintainers want these changes. Spend the time looking through the repo's issues, make sure you've searched and validated that this really is an issue, and if there's no mention of it, open up an issue. Tell the maintainers you're willing to fix it and see if they want your fixes. You may find that maintainers actually do not wish for you to participate, or others, they may want you to fix it but in a completely different way. As long as you're polite in your communication and you're very clear as to what you're trying to fix, you will find that often maintainers are very happy to have you come on board and help out. Okay, so assignment. I want to make sure people know how to do this. Okay, I wanted to make sure people knew how to do this like fun little bit. Add a file in your forked and cloned version of Megacorp to the repo contributors directory. The file should be named. Let's see, your GitHub username.txt. Replace your username with a good one. Okay, let's see. Add myself to the contributor. Okay, bam, 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 bam. Let's go in here and go in here. Okay, well I'm already there. ThePrimeagen2.txt. Oh my gosh. Oh my gosh. All right, there we go. There we go, we got that. Let's do that, let's go like this. Git add, git, whoopsies. All right, there we go, so we're gonna push this up, right? So I'm gonna do all this, I'm gonna push this up, push my changes to my GitHub, to an add contrib branch. Oh gosh, git checkout, add contrib. Oh, I'm not supposed to use checkout, sorry, it's just, I can't help it. I can't help that I do. Who the hell does that? Noob. Noob! Noob! He's a noob! I'm not even sure. Oh, I copied it from the boot.dev site. Remote add origin. All right, there we go. Fixed. Fixed. You wouldn't understand. Fixed. You wouldn't understand. You don't understand because you're a sore loser. Boom. I think it told me to create a pull request. Let me just make sure that that's what we're doing here. All right, there we go. All right, with the pull request open, submit the test. All right, there we go. Run all checks. Let's go. Owned it. Head. Mean where me at now. For those that don't know who Grug is the best. I always go down here and just read this line whenever I think of Grug. Apex predator of Grug is complexity. Complexity bad. Say again, complexity very bad. You say now, complexity very, very bad. Given choice between complexity or one-on-one against T-Rex, Grug take T-Rex. At least Grug see T-Rex. Complexity bad. All right, let's go like this. Okay, for example, you should be on main branch of your local clone of your fork of Megacorp repo, which means head is pointed to the main branch. Like all things in Git's Eternals, head is just stored in a file right here. Manually check to see what's in head. Yeah, let's do that. Cat git check out main git cat dot git. I think it should be the name of the thing. There you go. Yeah, it's just a path to the branch or the tag, if I'm not mistaken. Gat. Yeah, you gotta gat it, baby. You gotta gat it. Get that son of a B. All right, let's see if that just works. Okay, what did I didn't read. All right, what's the thing? Oh, git branch D add. I must have missed deleting that. Did it say to do that? Okay, my bad. I didn't look. I did not, in fact, look. We're going grug no read. All right, git reflog command, pronounced a reflog, not reflog, is kind of like git log, but stands for reference log, and specifically logs the changes to a reference that have happened over time. The default one is the head, by the way. Grug no read, grug never read. Where head is now, 1 move ago, 2 moves ago, 3 moves ago. You are already familiar with how git log works, how it shows your current branch and all the history of the commits. So if I had a brand new repo with 3 commits, A, B, and C, and I execute log, I should see the following output. And if I execute reflog, I should see this following output. Is reflog just a verbose log? Well, no, it's actually not. It's very, very different. And to illustrate the point, let's remove commit C. I can remove commit C by using git reset. I can walk back 1 branch, and as you can see with git log, I now only have B and A. But if I use git reflog, you'll notice that I don't have 2 entries. I actually have 4 entries. I have A, B, C, then back to B. And notice that it contains the command I use to get to B, which means that if you need to get the contents of C, you can actually use some of the plumbing of git plus reflog to be able to retrieve back out the contents of C, even though it's gone from your branch. I cannot tell you how many times reflog has saved my bacon by walking back and getting some commits that have been long forgotten. So what is reflog? Well, the definition from Git SCM is reference logs, or reflog, records the tip of branches and other references whenever they are updated. Or in layman's terms, reflog tracks the changes of a branch or other references being head. This means as you move your head around from branch to branch or from commit to commit, it tracks every last little step. I personally only ever use reflog to look at how my head has transitioned over time and rescue out a commit if I need to. All right, assignments. Run git reflog to see what its output is. All right, here we go. Git reflog. Look at that. Look what it is. Going from add contrib to main, from main to add contrib, to this commit, to the clone. Cool, right? You get to watch it kind of move around. It's kind of cool. I like it. Reflog is nice, and it's really not all that bad. All right, switch to a new branch off of it called slander. Git switch C slander. Look at that. I remembered to use that. Let's see. Create a new file called slander.md and have this one. All right. Vim slander.md. Paste that in. Megacorp CEO Lane enjoyed the live action Last Airbender movie. This Megacorp CTO Primeagen is a fan of The Notebook. Okay. Lane may or may not had a little bit of fun editing some of these things. Okay, I don't know if I didn't choose all of the stuff. I'm just saying, The Notebook's not a bad movie, okay? What? I feel... I even have to commit it. Okay, it's not bad. Okay, it's not bad. Alta movie was a good, terrible movie too. Did you cry? I didn't cry. I'm not crying. Slanderous filth. I'm not even sure if I spelled slanderous right. Boot.dev, run that. Okay, what am I not even doing here? All right, expected this. Contains all this one. Oh, I had to do b.slander. Goodness gracious. Reset, soft. Head. Okay, I gotta start reading. You guys are not helping me. B slander. You guys gotta quit. But by the way, did you see that nice usage of git reset soft? Huh? Did you like it? I could have git commit amend. I could have. We could have amend. But this one is great. Okay, it's okay. It's okay to cry. I don't cry. I work out. I know we could have amend. Okay, but we didn't. Okay. Delete branch. Have you ever shipped a bug to production, main branch, created a new branch to fix it, bug fix, fixed the bug and committed the changes, switch back to main, accidentally deleted the fix bug branch. All right, switch back to main and delete your slander branch. Git branch D. Whoopsies. Git check out main, git branch. Oh, I'm supposed to use switch, but I can't. I cannot use switch. Okay? I can't use switch. I can't use switch. All right. I want to use switch. Boomer brain, I know. So you've deleted your branch that had a unique commit on it. All is lost, or is it? Remember, git reflog keeps track of where everything has been. So let's do this. Git reflog. Look at this bad boy. That's where we did this one. Look at this commit right here. The commit's right there. The commit is right there. Okay, that means what we could do, like here's one way to do it, which I'm not saying this is the way you should do it. I'm just saying this is one way you can do it. You can go like this. You can go like this. You can go git cat file -p. Remember when we learned about all of this? And you can actually go through all of the little internals and snatch out the slanderous file, git cat file -p. Look at this, right there. There's me enjoying the notebook. Right? We were able to plumb through things if you wanted to. If you wanted to get deep in there and kind of go through the whole thing, you could. So there we go. We grabbed that. And so we can actually grab this and do that and do a recovery message, right? So I could do this, right? There's other ways I could also do stuff, right? This is just one way. You could also git merge. And since I already have this thing, I could actually just merge over that change into it. We're not going to do it, but you could imagine we could do that. So instead, I could just take the contents of this one file and I can remake it if I wanted to as well. Even though it's not true, commit that file with B recovery. Git add this commit -b recovery. Boom. Confettied out of my mind. All right, cherry pick would have been what I would want to do. Really? I would have just merged it over. Right? I mean, it just depends. Do you want the history or do you not want the history? Like, what happened if there's 10 commits? Then you have to cherry pick all the commits. Let's see. Using git internals is exceptionally inconvenient. We had the copy and paste from cat file 3 times. I would not recommend doing it this way. I just wanted to drive home that at this point, you can always drop down to the plumbing commands if needed. Luckily, there is a better way. Git merge. I just haven't talked about cherry commit. That's why we haven't talked about that. So I can do reflog this one, find the commit, that one. So I can do git cat file, do all this crap, which we don't want to do. I can also do this, right? I could have just merged over exactly what it said from reflog, right? Let's see, do I still have that reflog thing or did it open it in one of those windows? I think it did one of those windows, right? Yeah. Do I do no pager? No page. I can never remember what that line is. Oh, that's right. You don't do it there. It's a git no pager. There you go. So as you can see right here. So I could actually do git head at the second position back, right? Why does our git reflog allow us to potentially recover commits on deleted branches? Because it keeps a record of where the head has been? Yes. That's what it is. So there you go. Little fun reflog stuff. Merge. All right. Let's see. What can you merge with? Only tags, commits, branches, a commitish. Commit, tag, reflog entry, anything that can resolve to a commit. So that's why you'll see me use the term commitish quite a bit in this course. All right. Working with Git is a dream when all of the developers on the project are committing changes to different lines of code. Things get a little hairy when changes are to the same lines are made at the same time. One commit isn't the parent of another. Let's break some stuff. Remember, Megacorp is enterprise CMR service. Backed by the power of Git. Essentially, it means that we store lists of customers' data in a Git repo. Truly cutting-edge stuff. You should be on the main branch. Create a new branch called Add Customers. All right, Git branch. No, wait, it's Git. Is it Git switch? See, there we go. All right, there we go. We got that one. And we're going to grab this one to customers CSV. All right. All, is it all? Like that one? Yeah, there we go. So we're going to add it to all customers, and then we're going to also do orgs partner.txt right there, boot and startup. So we're going to do orgs partners.txt. There we go. Beautiful. We've done those two. Commit your changes with the thing C. Okay, we're going to kind of cruise through these easy parts because I assume at this point you guys understand adding, committing, doing all that because this is all easy stuff, right? None of this stuff is crazy. All right. Git status, git add this, git commit. I think I said C, right? Yep, C. Such Carson. Much HTMX. All right. There we go. And now we're going to switch back to main, and we're going to do this to customers. Git checkout main. Go back to here. Edit this thing. Jump up here. Customers all. Add JSON gross. HTMZ contributor. Git add this. Git commit. What do we need to do? With D. That's right. D. JSON is better than Carson. More like Carse off. All right, so do you see what we've just done here? Do you see how this is going to cause problems? So if I go like this, git log one line dash p one main, you'll notice that I edit customers with one line right below company title. If I do the exact same thing, but I do it with the add customers branch, you'll notice that I do the exact same thing to the same customer files in the same location. In other words, we both modified the same line. And by modifying the same line, Git doesn't know what to do because Git doesn't understand anything about code. It only understands things about modified lines. If two lines have been altered in some way, it creates a merge conflict. There we go. I believe that should just work. There we go. And let's go conflicts. Yeah. So merge conflict occurs when two commits modify the same line and Git can't automatically decide which changes to keep and which change to discard. Consider the following commit history. ABC, this is pretty much what we have now, except for it's A, B, C, and D. The main branch has something like this. Is nice, returns this one. The feature has this one, is nice, 420. Right? If we try to merge feature into main, Git will detect that the return line was changed in both branches independently, which creates a conflict. So this is good. This is good to understand, right? When a conflict happens, usually as a result of merge or rebase, Git will prompt you to manually decide which changes to keep. It's okay when the same line is modified in one commit and then again in a later commit. The problem arises when the same line is modified in two commits that aren't in a parent-child relationship. All right. If the line changed in B was all the conflict by change in B's parent A, the HTMX guy writes an essay about it. That's true. Carson will probably write an essay about it. That's perfectly fine. Git knows A happened first, then B. Yep, that's the thing. You can't conflict yourself like that. Right? You just can't. All right. If two developers on separate branches modify the same line of code, what happens when the branches are merged? HTMX guy relaunches the project with a new name, fax. It's perfectly fine. False. Conflict arises. There we go. Assignment. It was stupid Greg, who merged his new customer data into main, commit D, while you were working on your new customer data in add customers branch, commit C. Because his change made it into main first, stupid Greg, it's up to you to resolve the conflict, stupid Greg. Now, because your manager is a Luddite that learned to code before version control was invented, he asked you to merge instead of rebase. Absolutely. This is all true. Switch to your add customers branch and merge main into it. All right, there we go. We should get this one. Let's go. Git, check out, add customers. Hey. Git, branch, D, add contrib. Wait. Why is contrib still there? I thought I just deleted it. Why is there multiple add customers? Whatever, that's confusing. Whatever, I don't got time for this. Damn it, Greg. Leptos mentioned. Leptos potentially mentioned. Git merge main. All right. Boom. We got ourselves a conflict. Okay. If we run git status, you can confirm that we're in a conflict. So if I go git status, you can see right here, you have unmerged paths. Fix the conflicts and run git commit and use git merge abort to abort the merge. So we can actually stop the merge by doing that. Get out of here. Okay, there we go. Git run status like this to confirm that you're in a conflict. We can see that. So let's run this thing. Boom. Oh, wait, what? Oh my gosh, this thing is incorrect. Lane! Lane, we have a problem. This is wrong. Our direction somehow got out of stuff here. I know, which means I can go like this: git merge abort, git check out main, git merge add customers. There we go. Kind of BS, Lane. All right, here, I'm gonna go back here. I'm gonna report this. Wait, does it? Am I wrong here? Maybe I just didn't. Hold on, git merge abort, git merge abort, git check out. Maybe I did this wrong. Yeah, I used the wrong one. Lane, it's not right. Lane, you're right. You're right this whole time. I'm the bad one. I'm the bad one. I'm the bad one. Shut up. Git check out, you dumb fuck. I know, I messed up. Isolate the changes and merge correct. You merge yourself correct. Resolving conflicts is a manual process when they happen. Git marks the conflicted files and asks you to resolve the conflict by editing the files in your editor. So here we go. Open up the customers all and you should see this. All right. So here we go. Here's our customer. So you can see you can see a couple things here. Just so everybody knows, in a merge conflict, this represents hours is the top one. Hours is where our head's at. Here's the change in hours. The change ends with the equal sign. And then this is the one, and then the bottom one represents the incoming branch, theirs. So theirs is main, ours is head, and this is the change in theirs. This is the change in ours, okay? It's pretty good to know those things, all right? Let's see, delete the conflict markers and leave both changes and Greg's change in the file. It should look like that. So you can actually have both changes at the same time, right? Nothing says you have to change it. It's up to you to resolve how to do this. You can accept both, totally reasonable. Save file and do this. Okay. Yeah, we can accept both. There's nothing that says you can't accept both. Right? All right. Resolution. After manually editing any conflicting files, sometimes it's more than one file or more than one section of a file, you simply need to add and commit the changes. This tells Git that you've resolved the conflict and can continue with the merge. Okay. Awesome. We can do that. So let's resolve with this nice message right here. It's a nice, beautiful message. Git add this, git commit -m, all of that. Oh my goodness, stupid Greg. Oh no. All right, there we go. Apparently, I don't know how to do that. There we go. Got it, first try. And now we can do log to examine the homework. You should see C and D, and commits come together and E commit. All right, git log one line. Look at that beauty. And then we can go one line graph. There you go. It all comes together in E. We resolved the conflict. Bada bing, bada boom. Very nice. Absolutely liked it. Absolutely enjoyed that. All right. All right. You just ran git merge, and you're now seeing this. Okay, I just realized what was happening. I was like, wait a second. Which code in the conflict is yours, and which is theirs? So if we ran git merge, that means this is ours, this is theirs. The top is mine, the bottom is theirs. It's all mine, stay away. I prefer that answer, honestly. All right, you just ran git merge and you're now facing this conflict. Oh, let's see, what does head refer to? It's another name for the master branch, no. It's another name for the main branch, no. It points to the latest commit in the other branch you're comparing to, no. It points to the current branch's latest commit, boom. It's pointing to where head points to, everybody knows that. It's that easy. Back to main. Your manager at Megacorp is not happy. It turns out you were never supposed to add customers to the all.csv file at all. Only Greg is allowed to do that. Stupid Greg. This is what you get from making changes without 10 design meetings and an alignment of stakeholders. What were you expecting? To be productive? This is Megacorp. Process over productivity. Get back in line. I don't want to hurt anybody's feelings. But at the same time, I know a lot of people just got bruised by that one statement. I'm sorry. I'm sorry that, right? There's some of you that hurt. That paragraph hits home? I know it does. Well, let's just say I've written a design document for the dumbest thing. Stakeholders are okay in the 10th design meeting, but have problems when the implementation hits prod. Always. Every single time. Assignment. Let's fix our hastiness by doing a git reset hard of the merge commit. This will allow us to take a different approach to resolve the conflict. Luckily, we haven't borked main yet. We just need to fix our add customer branch. While on add customer branch, reset to commit C. All right. Let's do that. Oh my goodness. Let's go like this. Let's go. What is it called? Megacorp? Yeah. Git reset hard. Head tilde 1. There we go. We're back to C. Everything is great. We're looking good. We're feeling good. There we go. We do all that nice stuff. So I literally just took the change, moved back my branch once, and discarded my index and my work tree changes. Bada bing, bada boom. Easy peasy, pumpkin seedsy. That's just that. All right. Let's fix our hastiness by doing a hard reset. Yeah, we already did that. Luckily, we haven't borked main yet, so we'll just fix. All right, here we go. Try merging main into customers again. This time, resolve the conflict by keeping only the changes from main. I want to see something because I may accidentally have re on, and if I do, then it's going to say it's all fixed. Nice. I don't have re on. Git config list global grep re. Oh, I do. Wait, shouldn't re take care of that? Doesn't wouldn't re jump into that? Am I confused here? Am I being... What? What? I thought it did. Well, then why didn't it should have auto-conflict it? Record resolution was solved. Was added. Weird. Why didn't it auto-resolve right here? Shouldn't it have just auto-resolved? Oh, wait. Oh my goodness, I am so stupid. I am so stupid. It did. It automatically using previous resolution. So if I go to customers, oh my goodness, I'm so dumb. Look at this. The conflict is gone. The reason why the conflict is gone is I knew I had re enabled. So since the customer doesn't have a conflict in it, we need to disable get config. I'm just going to do a local one. I'm just going to go like this. Add local enabled false. Right, so I'll just add a local one, so I still have my global one, so it still continues to do what it's doing. Git merge abort, then git merge main, which should now, there you go. I now have the conflict without taking over, and I should be able to just go into here, and I should be able to go to all, and now we have this again. So now this time we're supposed to select Greg's change, which is theirs, so I can go like that. Boom, Greg's change selected. There's some other ways you can do that make it easier, but this is good. So we're going to go like this. Find Greg, have this one. Boom. We're going to go here and go get status, git add this, git commit-m with that one. There we go. And then jump in here, do that. There we go. There we go. All right. I think that's good. All right. Ours versus theirs. In a merge conflict, ours refers to the branch you are on, merging into. Theirs refers to the branch being merged. This is important. Git merge their branch. Ours is the branch you're on, right? Git terminology. Last time, we manually edited the conflicting files. This time, let's use Git's built-in merge resolution tools to make the, use of the terms ours and theirs to refer to the branches being merged. You should currently be on add customers with this kind of history right now. Switch back to main and merge add customers into main. This would result in a fast forward merge bringing C to E into main. Delete add customers. All right. Git, check out main, git, merge, add customers, git, branch, delete, add customers. Boom. Look how fast I am. All right. So let's do an ours versus theirs merge because this is really good to know. All right, so we got a multi-conflict so far. We've only dealt with one conflict at a time. That's small potatoes. Let's see what happens when we have multiple conflicts to resolve. All right, so let's switch to a new branch off main called delete records. Git switch C that, and then let's see, edit customers all and delete the JSON line. Okay, there we go. Deleted it. Edit org partners and delete the boot.dev record. Okay, org partners. There we go, boot.dev record, boom. Oh, we want to keep the line. There we go. Let's see, switch back to main and edit customers. Oh, commit the message with F. We got to commit the message with F. Get status. So I'm gonna use what's it called, fugitive for this part because it's just easier and faster, and you guys don't really care about committing, right? What do we need to do? Delete those records, right? I just prefer that. Git check out main. Just makes life easier being able to use that because we can move faster. There we go. All right, so we have this one. So edit the orgs partner and add a boot.dev record to Sales Inc. Oh, change it. And change the boot.dev to Sales Incorporated. Yeah. So I can go like this. Sales Inc. There we go. We did that one. So now we should have this one and do a G. There we go. And CCG such Inc. There we go. We now have that one. Run and submit the test. There we go. Wait, is that all we had to do? Did I miss something? I thought we were doing multiple. Oh, we forgot to do that. We forgot to do that one. Carson Gross. That's right. All right. Customers all and go Carson Gross. Go in here. S. There we go. So all I did was I just did right there. For those that don't know, I just did a git commit amend no edit. And so by doing a git commit amend no edit, I simply just I know I wrote shut up. It just means I merged in that change, right? So I merged in that change right there, and I did that one. You know, because I'm not gonna lie to you, it is very nice to be able to use the tools I'm used to. You know what I mean? I don't always do everything via the command line. There we go. All right, so we did all that one. We have these nice commits. Now we have these two things, and so now all we have to do is just cause the conflict. Let's go. Wait, what did I do? Oh my goodness. Here, I forgot to do that. There you go. I'll show you what I did. Git status. So I have this one. Git add this one. Git commit amend no edit. There we go. So I kept the same line, just not everything else. Wait, what am I doing wrong here? Carson Groves, HTMX creator. What? I'm not good at reading. Okay? I've never said that I was good at reading, all right? First try. Let's go. First try. Check out the conflict. We've manually edited files to resolve the conflict, but it turns out Git has some built-in tools to help us. The git checkout command, can check out the individual changes during a merge conflict with theirs and ours flag. While on main, merge delete records. All right, git merge delete records. So now we should have two conflicts. You can see the two conflicts right here. Git status, you can see the two conflicts right here. Unmerged path, both of those. Git diff should show each one of them having the problem right here, which means that I can go like this. How do we do this? We're going to keep theirs for customers all and keep ours for partners. So I can go like this, git check out theirs. That's going to be customers all. There we go. So now I have theirs, and then ours is going to be orgs partners. There we go. So now if I go like this, git diff, you'll notice that we have no changes. Everything looks good. Git status, perfect. Git add this. If you look at them in here, you'll notice right away. There we go. So that's the deleted one that we kept. And then from orgs and partners, you'll notice that we have Sales Inc. from our side. So Sales Inc. from our side, deletion from their side by using git checkout theirs and ours. It's pretty nice. What do we need to do here? We need to do this with an H. Let's see. Such resolution conflict. You'll also notice something else. Notice that orgs is not a part of any changes here. Do you see that? There's no orgs a part of changes. That's because that wasn't changed. By accepting my change, this commit doesn't contain any change. Does that make sense? Because that file only had one change to it, which was my change. So by me accepting it, the difference between these two goes to 0. It's good to know. So that's why sometimes those things can change and it can look a little bit confusing. It's actually not all that confusing. It just means that something goofed up. Oh my goodness. How am I so bad at this? Oh yeah, let's go. All right, something you may have noticed when resolving merge conflicts is that you don't get the standard merge commit message, right? No, you don't. You have to manually provide a message. Typing, it actually makes sense when you think about it. Git doesn't know what you did to resolve the conflict, and it's encouraging you to document your change via the message. That makes sense, right? I think everybody understands that. What commit message is used after resolving that? The standard one, unhinged commit message. For example, we should have rebased instead. I actually like this one. That's my favorite one. But we'll do a custom commit message. Now we're going to do rebase one. This one's going to be a good one, all right? Rebase, full disclosure, a lot of Rebase's bad rep comes from conflicts. Fear not. It's nothing you can't handle with just a smidge of practice. Rebasing feels scarier because it rewrites Git history, which means if you're not careful, you can lose work in an unrecoverable way. But as long as you understand what's going on, it will make your and your team's Git history cleaner and easier to understand, and more so, easier to revert when needed. It is impossible to revert your change with several merge commits and all that. I've seen some pretty nasty ones where you're trying to do that. Assignment. Create a new branch called band, copy of main branch, and add a new file, customers band. All right, there we go. Skibidi toilet merge when git check out -b band. I didn't use switch. It happened, but we're going to keep on going for it. Band.md, is that what it was? No. band.csv. Boom. Put it in. Yeah. Sam Controlman. Closed AI. Classic. Really true. Absolutely, actually true. There we go. So we have this one. We're going to do git message I. So I'm going to go in here, CCI, control man. There we go. And so now let's go like this. Git check out main. Do one of those. And then how do we want to do here? We want to have the same Sam controlman, but a different one of these. There we go. And then jump up here and go C, H. Oh, no, wait. J. You're right. H comes before. H before I, except after C's. Right? Is that how it goes? I'm on chapter 7, section 4 right now. All right, well, let's go. Let's go. All right, so there we go. So we have all this one. So we should be able to run this to make sure it's all actually the way we want it to be. So I'll go like this. We'll run this bad boy. It's going to do all this. Bada bing, bada boom, bada bing, bada boom. All right, beautiful. We are just crushing through this course, okay, people? We're feeling good. Make the conflict. Before we move on, I just want to remind you that it is often, not often, that you'll be creating your own conflicts. We're doing so because you probably don't have any friends to practice with. I don't actually, kid, Arch users. But even if you do have many developer friends, let's just make all the changes ourselves so you don't need to bother them. Let's see, you switch to a new branch, fix bug, which is just a copy of main. While you're fixing the bug, someone else merges their changes to main. You fix the bug and it happens to edit the same file. You open up a pull request, rebase, fixing the mains, Git tells you the conflict, you resolve the conflict, you complete the pull request. This is like standard operations, right? We all know this one. So we switch the band branch, rebased it into main. Which rewrites the Git history of band branch, because remember, it needs to add that extra commit. So there we go. We're going to do that. All right, so we're going to go like this. Git check out band right there. Git rebase main. My gosh, we have a conflict. Look at that conflict. Oh, no. Oh, no. So if I go in here, I look at my status, you can see right here, we have problems, don't we? We actually have problems. All right. Well, you should get a conflict. You might also notice something odd. This time, head pointed to main's change rather than band's change. All right, so let's just jump back for a quick second and just validate this, and I'll explain why. All right, so notice that this should be band, protagonist should be main. Look at head, has protagonist, which is main's change. Why is ours mains, even though we did a rebase on band? Why isn't ours our change? Why is it main's change? Does anybody know? The commit comes from main? No, because that would make it theirs. We move to main, then replay our commits on it. Boom, let's go. So this is from section 1. This is why section 1 is so important, is when you rebase, your target branch becomes your branch that you're on, and then you replay the source branch's commits starting from the merge base and forward at the tip of your target branch. Therefore, let's write this out because it might be a little bit easier to visualize. So this is the most important part. Remember, so when I'm on band and I do git rebase main, what happens is I actually check out main, which is going to be at the tip. I grab the differences between, band and main, and then I do band. If there's multiple commits, I'd actually attach each one of them to the front. So that'd be like band 1, band 2, band 3, right? So I'd get them all on there. So my branch now looks like this, where the tip of main is now the new merge base, as opposed to wherever I branched off before, which could be somewhere in the history. So that is why ours is theirs and theirs is ours during a rebase conflict. It's actually not confusing if you know how rebase works. It makes perfect sense. It's that you have to switch branches and then play the commits. All right, let's see what happens here. Let's see what our assignment is. Switch to the new branch, do this. Copy a branch and add the new file customers, this. We've already done this. All right, there we go. Assignment, switch to band, rebase on domain. While you should get a conflict, you might also know something odd. We already talked about why. If you had merged main instead of rebase, head would still point to band. Correct, because merge does not swap replay. It just adds or creates a merge conflict into a single point. There we go. That's good to know. However, you kind of need to think in reverse with rebase. Theirs represents the band branch, which in reality is our change. So we're going to run branch. You'll notice that you're not on a branch. That's right. That makes perfect sense, right? Because remember, it has to create this no branch situation where it takes main and then starts applying commits to it. So you're in a no branch situation, right? There we go. Bam, look at that. Look at that confetti. Man, first try. The same git checkout theirs and git checkout ours commands we used in merge can be used to resolve conflicts during a rebase. You may have also noticed that if you open the file in your editor, depending on your editor, it has UI features to help you resolve the conflict. Yep. So this would be VS Codes. Accepting incoming changes is the same as checkout theirs. Accepting current changes is the same as git checkout ours. That would be in theirs. I don't know how to use VS Code. All right. Assignment. Use the appropriate git checkout command to overwrite the banned branch's changes with the changes from main. So since it's main that we want, git status, git checkout ours. Our branch. Remember, we're taking main. All right. There we go. Let's see, and then hit him with the rebase continue. Git rebase continue. There we go. And then we git log to see the new commit history. Git log. Look at how good that looks. Look at that. Look at how good that looks. All right. You may have noticed something. Did anyone notice that I was gone? Why was I gone? So theirs is main. No, ours is main during that situation. The number of rules indicates that this isn't intuitive. No, it just means that it can be potentially complicated. Anything that is sufficiently complicated requires you to learn. If you only worked on things that are intuitive, you would never use recursion. Like, that's that. It has nothing to do with it being, the number of rules have no indication whether it's intuitive or not. Understanding the underlying reasoning why or what happens makes it intuitive to understand. I understand how Rebase works. Therefore, ours versus theirs is intuitive to understand. But that's because I have a understanding of what's happening. Expected state to contain this. Wait, hold on. Branch. Oh, I'm not. Oh, I haven't. Git rebase continue. Oopsies. Did I not get status? Did I not? There we go. We've continued it. Git status. Awesome. All right. Let's do this. Perfect. We're in. We did it. Why did the deleted commit? What happened? Why was I gone? So for those that don't understand, where's I? Why is I not in here? The reason why I is not in here, remember this, is that I was a change where deleted a specific record. And what did we do? We ignored that one change. By ignoring the one change that I was, we've dropped the entirety of the record. Since there's no empty commit. When the commit is empty, the commit is dropped. Right? Yes, we are working on the banned branch. We started to rebase a band onto main, meaning we're rewriting the history of band to include all the changes of main. We effectively removed all the changes of the I commit by choosing to keep the changes from main instead of band. We continued to rebase and realized that the I commit was pointless because we're rewriting history anyways, just remove it. There's literally nothing in it. Right? There's no I in team. That's why. If our changes had been more complicated, say we kept some of the changes from I commit and overrided others, then Git would have kept I in the commit history. Why did Git remove our commit? Because this is Megacorp and we have a strict no commit policy. Because Rebase is scary and it should be avoided at all costs because it was essentially empty and Rebase is okay with rewriting history. Bada bing, bada boom. There's nothing to commit. There's nothing there. It's just making life easy, right? What if the only part of the commit had been undone during the rebase conflict? What if only part of the commit had been undone? Then the commit would have still been removed. No, the commit would have remained in the history. Let's go on to this one. Okay, let's clean up our branches. Remember, during the rebase of band onto main, we actually discarded the changes of band, which actually means that band is now just identical to main anyways. So yeah, so we're going to switch back to main and delete band, right? Git, check, out, main, git, branch, D, band. There we go. All right, so let's delete some branches. We're going to delete git, a branch. Okay, we did that one. And now let's go over here. Let's go. There we go. All right, let's move on. All right, disable or re. Well, it should have already been disabled. This section does need to technically go back because I already did a local one of those. I don't think I deleted this. I'm not sure if I even have it, but here, I'm going to get rid of it just in case, right? Repeat resolution setup. A common complaint about Rebase is that there are times when you have to manually resolve the same conflict over and over again. This is especially prevalent when you have long-running feature branches and even more likely multiple feature branches that are being rebased onto main. Re to the rescue. The git re functionality is a bit of a hidden feature. By the way, this is directly from Git SEM. Can you believe that? One of the most useful features of all time is just hanging out. Here, hold on. Git re. There we go. Let's go Git SEM. Look at this. Functionality is a bit of a hidden feature. Wait, you're telling me I didn't have to resolve it every time? Yikes. The name stands for reuse recorded resolution, as the name implies. As the name implies, it allows you to ask Git to remember how you resolved a hunk conflict so that the next time it sees the same conflict, Git can resolve it automatically. In other words, if if enabled, a re will remember how you resolved a conflict, applies to rebasing but also merging, and will automatically apply that resolution the next time you see the same conflict. Pretty neat, right? Am I right? All right, assignment. Create a new branch off of main called faves. All right, Git. Check out b faves. Didn't you switch? Suck it. New commands. Create a file called faves.md with the following contents. Let's go. Jump back in here. Go here. Wait. Customers. Okay, customers. Faves.md. There we go. Cool. Commit that with message K. Create a copy of faves branch called fave2. All right, here we go. We'll go in here. We're going to go here. We're going to CC. We're going to K. My faves is the Heisen. Right? Boom. Boom. Git check out -b faves2. So now we have the same branch twice, okay? Okay, the same branch twice. All right. Now we're going to switch back to main and create a file called faves with different content. All right, here we go. Git check out -b main git Manny main. Oh crap, I created Manny. Git check out main git branch d Manny. Got him first try. And then go in here and put that in there and git status, git add this, git commit -i. What is it called? Should be with an L. Take the L. Take the L. Bam. All right. So now we have these right here. We have main on L, faves on K, faves2 on K. The changes from L and K naturally conflict. Run the test. Let's go. We're going to run the test. We're running the test. Let's go. We're running it. Confettied out of my mind. Are you ready for the confetti out of my mind? Enable the re feature by running the following command. All right, so I'm just going to go like this. Git config unset local re enabled because I have a git config list grep re. There you go. I already have it globally true for everything because I like the setting. Switch to faves and rebase it onto main. All right, git check out faves git branch or git rebase main. There we go. So notice this. We're going to do this conflict. We're going to be doing this recorded pre-image for customers. There we go. We're getting ready. We're re-in. Okay, so we have a conflict. Let's do this. Let's solve this conflict. Notice how there, let's see, hold on. Accept both changes. All right, let's accept some changes, okay? Yes. Changed. Git, add this, git, rebase, continue. All right, so now what are we gonna do with the naming? Stage and rebase, leave the commit message as K. All right, boom, got it. Note that Git may automatically open a file on your editor in which you can edit the commit message. Simply save and close and continue. When you're done, you should see something like this. So you should notice that we should see something like this. Recorded resolution. Yeah? We're read out of our mind. Now, switch to faves2 and rebase it onto main. All right, git check out faves2, git rebase main. Now look at this. We have a conflict, but it's already resolved, right? It's already resolved because we already resolved this specific commit. So now we don't have to resolve it again. It already knows what to do. So now I can do the exact same thing. I can do the whole git rebase continue. So re is really, really nice because it's one of those things that if you do it right, it is fantastic. Why is re disabled by default? Because it can lead to confusion. So if you don't know what it is, it's probably dangerous to have it created. What comes with re? Let's say you have a change that results in a conflict, but you want to resolve it differently. but instead it automatically resolves it for you. You could feel pretty confused, right? So that's why it's nice to have it as a feature you opt into, because that way you don't accidentally screw it up. All right, let's go on. Merge back in. Phew! Now we have two branches, faves and faves 2s, that are ahead of main in the same way. We don't actually need both faves and faves 2, so switch back to main. Try deleting fave 2 with lowercase d flag. Now actually delete it with capital D. I'm not sure if we've actually done that. Git check out main. If you don't know, if you try to delete a branch that ends there, it terminates your commit history. It'll be like, yo, you probably don't want to do that. And so you have to give them the old capital D. And when you give them the D, it then does it. Then merge faves into main. This should result in a fast forward merge. Deletes the faves branch. There we go. Git merge faves. Git branch D faves. Boom. Let's go. Grab it. Paste it. All right, accidental commit. How with merge conflicts, you can commit the resolution, but with rebase, you have to do continue. Dude, I've done this so much in my life. I cannot tell you how many times I've done this. Dude, I know. I'm telling you, which is me telling me. I cannot help this one. How do you undo that? Dude, Dude, this is the greatest thing in the universe right there. This solves that problem. If you ever you've never done it, really? Oh my gosh! When I get rebase, when I resolve a conflict, and I do git add dot. It immediately I go git add rebase or git commit dash m, and I commit it, and I'm like fuck, and I just hate it. But if you just do a reset soft, remember a soft takes the commits changes, applies them to your work tree, and moves your branch back one, so you get your rebase right there. Now, I believe this has been largely fixed. I believe now you can actually do a rebase, continue even after you've committed it, and it just works. You get that new message instead. Before, it used to not work. I love this one. Why does git reset help you if you accidentally commit during a rebase? Because you can undo the commit and continue the rebase. Yes, exactly. That's why I love it. Okay, we're going to go over a quick bit of squashing, okay? Every dev team will have different standards and opinions on how to use Git. Some teams require all pull requests to contain a single commit, while others prefer to see a series of small, focused commits. If you join a team that prefers single commit, you'll need to know how to squash your commits together. To be fair, even if you don't need a single commit, squashing is useful to keep your Git history clean. Yes, and it makes it easy to revert. Again, if you have a feature that could be dangerous in production and it's spread out over 12 commits that have like 18 merge commits, it is really, really annoying versus just having one commit at the end. Squash it, easy to put in, easy to pull out, okay? What is this squashing exactly? Well, it's what it sounds like. We take all the changes from a series of commits and squash them into a single commit, okay? All of them, A, B, C, D to AX. Easy. Assignment. Let's get ready to squash some commits. Push your current changes up to your forked repo on GitHub, just in case your machine goes swimming. Don't skip this. Okay, here we go. Git, push, origin, main, go. All right. Create a new branch off main called temp main. Git, check out temp main -b. Let's go. All right. So now that we have that, we do all this. Let's go. Let's go. We're back in. To be completely fair, I am just absolutely... I have what someone... Oh, git check out -b temp main. Yeah, there we go. All right. How to squash. Perhaps confusingly, squashing is done with git rebase command. It may not be intuitive, but remember, rebase allows you to apply or reapply history. This will make sense more. Here's the steps to squash the last n commits. Start an interactive rebase with git rebase head or -i. I think they call it tac I in the military. Git rebase tac I head till the n, where n is the number of commits you want to squash. Git will open your default editor with the list of commits, change the word pick to squash or S, save and close the editor. The I flag stands for interactive and allows you to edit the commit history before Git applies the changes. Head till the n is how we reference the last n commits. Head points to the current commit. There you go. Does that make sense? Why does rebase squash? Remember, rebase is all about replaying changes. When we rebase onto a specific commit, head till the end, we're telling Git to replay all the changes from the current branch on top of that commit. Then we are using the interactive flag to squash those changes so that Rebase will apply them all in a single commit. Assignment. Megacorp executives do not like your last few commits. As a result, your manager told you to squash the last 3 commits, J, L, and K, into a new single commit message. J, redacted. Squashing is destructive operation, which is why you've decided to make the change to temp main before moving it to main. While on temp main, squash these three. Don't forget to pick or squash it and edit J redacted. Let's go. So I'm going to go like this. Git rebase. Oh, first, git log. So we want to go all the way to J. So 1, 2, 3. Git rebase I head tilde 3. Let's go. I always go like this. There we go. You'll notice right here, it says it right here that you can do that. S stands for squash. Use the commit and meld it into the previous. So that means S, let's see. How does this go? It goes, this one goes into the previous, and then this one, I forget exactly how these things end up. But either way, it ends up good. I forget the exact merging order. Redacted, right? There we go. There we go. So if I go git log, one line, you can see that J is redacted and the rest are all right there. Perfect, right? But they still can change the change set. So if I go -P, it still has the whole change set. It just doesn't have, what's it called? It just doesn't have the individual commits. All right, overwrite. Now that temp main is in the state you want, and hopefully you verified that with git log, we need to do what the boss asked. Delete the main branch, rename the temp branch into main, ensure that the temp main branch is gone, resubmit. Now, obviously, this is a very dangerous operation, so we're rewriting public history. We're doing it just for fun, because, hey, why not? But we're doing it, okay? So don't do that, by the way. Branch, delete, main, git, check out, don't actually do temp main, main. This is dangerous, okay? There we go. We did some naughty stuff. We squashed main, which means that because our remote main branch on GitHub has commits that we removed, Git won't allow us to push our changes because they're totally out of sync. Git push has a command called force flag, which allows us to override a remote branch with our local branch. It's very dangerous, but useful. Flag that overrides the safeguards and just says, make this branch as same as the branch. So by doing this, we're actually changing that stuff. And that could be, obviously, you would never want to do this to a main, okay? Just so you know. Go ahead and force push your local main to the branch on remote main. I know. By the way, you should never actually do this, okay? This is crazy, okay? Squashing is scary. When you squash commits, for example, A, B, C, D, and U into a single commit, you're removing history from a project, so all the changes are still there, but the individual markers of each changes are gone. It's one big commit now. In the last few lessons, we erased all the commits, meaning we can't go back to the individual checkpoints anymore, or you can't go back easily. We can still use Git plumbing and Reflog to actually rehydrate everything and re-put it back into it. We can, but we're just currently not doing that. When you squash commits, you lose history of the individual commits. That's what happens. You can still get it back. It's just that it's just non-trivial, right? When you squash commits, the content stays the same. Correct. The content stays the change. It's just that you change the commits. Yeah, never squash master. Never squash master. I put that in there so I could talk about it and why it's crazy. We did some weird things. Squash commits to main. Now let's do a common thing. Squash all commits on a feature branch for a pull request. If your team prefers single commit pull requests, we will likely be your workflow. Create a new branch off main. Go about your work. When you're ready to get your code into main, squash all your commits into a single one, push your branch to the remote one, open up a pull request, merge it once it's approved. All right, assignment. First, let's just do points 1 and 2. Megacorp needs to add a new feature to the content management system. Specifically, they need a script that will automatically scan for sensitive information in the repo. Create a new branch, add scanner off of main. All right, this is where things are going to get a little bit wild here. Git branch or check out -B. I know it's switch. I don't want to do it. I'm too much of a Luddite. All right. In the scripts directory, there's a file called scan.sh. Replace the to-do comment with this. All right. I can't help it, okay? All right, in the scripts thing, scan.f8, write the script. There we go. We got it. All right, there we go. We have that one. Run the code from the root repo. All right. Look at that. We have, oh my gosh, we have so many social security or credit cards. So many cool credit cards just flying everywhere. Finally, now we can do social security numbers, add another few lines to the script. All right. There we go. Run the script again to ensure it works. Oh, did I not? Oh, I forgot to commit. I forgot to commit. Hold on. Okay. Credits. There we go. Wait, why isn't that working? Oh, did I accidentally delete? Oh, crap. All right, there we go. Now we can paste this in. There we go. All right, there we go. So now I can go CC, and this one should be J, right? This should be L. Yep, okay, so this one will be L. This one will be Social Security numbers. My bad. My bad, I accidentally did that one out of order. Now we should do phone numbers. There we go. Add one for phone numbers. Added it for phone numbers. There we go. There's some phone numbers in there. CC, and this is HJKLM phone numbers. There we go. Looking good. Run the script one last time. Make sure it works. There we go. All right. I accidentaled your commit. I know. It happens. There we go. All right, so we got ourselves set up for this nice next one, Squash series. Remember, the full workflow we're going to be doing, which we already talked about this. Creating your branch, making your commits, squashing it, making it a pull request. Let's tackle point 3. Squash KLM into a single new commit starting with K. Remove L and M. All right, so do it again. Git rebase I head tilde 3. Do these ones. SS. There we go. And go into K. There we go. Bam, 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 bam. Got those two. We are rewriting the history of our own branch. Let's see. To make it look as if we did all the work in a single commit. This is normal and fine because it's our branch. Yes, it's our branch. Now it's okay to do. Right? Now it's okay. Before it wasn't okay to do, and we did it on main, which we shouldn't have done it on main, but it's gave me something to talk about. Gave me a reason not to do that. Our branch. All right, so now we're going to do 4 and 5. Use git push to add scanner and open a pull request. All right, git push origin, add scanner. There we go. We're going to do that, and we're going to go to backend. We're going to go to GitHub, ThePrimeagen, which update Mega Corp, and there we go. Pull requests. New pull requests. Add scanner. Let's go. Create pull requests. Create it. Let's go. Looking good. Looking good. Oh my goodness. How do you not have my repo name? I thought you had it. All right, I'm just going to copy that one and bring it back in here and go ThePrimeagen. There we go, and run all checks. Oh, am I doing it? Oh, to main on your Megacorp. Oh crap! I did it on your Megacorp. I didn't read the instructions good. I in fact did not read good instructions here. I in fact did terrible instructions reading. There we go. Apparently I can't change where my remote is pointing to, which is kind of weird. That's fine. GitHub, ThePrimeagen, Megacorp. There we go. So I effed it up. Apparently the UI doesn't let you change the base. Reading instructions are required for squares. Yeah, it's losers. Add scanner. There we go. Sorry, the previous one didn't required me to do it on a different one, so it got me a little bit confused. All right, there we go. Merge the pull request. Remember, we did all that one. Now let's tackle point 6. Merge your pull request from add scanner into main. You can also do so by clicking the big green merge request button. When you're done, you switch back to main branch locally. Here's the scary part. Delete your local add scanner branch. Pull the latest changes from main, and your local main branch should have now commit K. Yeah, some people get freaked out. It's okay. When you have centralized merge stuff, it's not a big deal. Hit the big green button, confirm the merge, git check out main, git a branch, big D delete, add scanner, right? Boom, get it out, git pull. Oh my gosh. I didn't set that. There we go. Git pull. My branch wasn't pulled. There we go. Look at that. Good? Yeah. There we go. We got the energy. We got it all done. Absolutely fantastic. It's all in. All right. Wait, did that mean I did it? Okay. Stash. All right, so now we're going on to stash. Are you guys ready for some stash? All right, you've been at Megacorp for a while, 3 whole days, and to your mother's surprise, you're still employed. Here's the workflow you've been using as a junior developer. Commit some changes to a feature branch. Open a pull request from that feature branch to main. Check out the new feature branch and start back to the next task. Today, however, is a big day. All right, today is a big day. Big day. The customers are complaining about a critical bug and the CEO saw you first. She asked you to drop everything and fix it immediately, but you've got a bunch of unstaged changes that you're not ready to commit yet, and you don't want to lose. What do? Many Git noobs would create a second clone of the Git repo at this point. A huge mistake. You're better than that. That's right. You are better than that. The git stash command records the current state of your working directory and the index staging area. It's kind of like your computer's copy-paste clipboard. It records those changes in a safe place and reverts the working directory to match the head commit, the last commit on your current branch. To stash your current changes, do git stash. Yeah, and stash list to list your changes. Don't look at that. My stashing workflow looks a little something like this. I usually have some amount of work that's in my index or my work tree, and I get a request in that says, hey, can you please investigate this bug? Or, hey, you need to pull in the latest changes, because if you pull in the latest changes, the feature you're developing will have a couple extra APIs that you need. Which means I'm gonna have to take my changes, create a commit, pull in the new changes, finish off the change I wanted to make, create another commit, then squash those two commits into one, or I could just stash my work tree and my index, pull in the changes, and then pop off my stash when I need to get back to doing what I was doing and finish the change I was trying to make. Now, the times that I don't do that approach, the times that I don't choose stash, which often I do, is whenever I had to pull in a change, but I'm already in several commits into a change I'm trying to make. Typically, I try to keep my changes pretty small, but every now and then you'll have like 1,000-line change. And whenever I have a big change like that, I try to make small commits along the way as nice checkpoints in case I screw something up so bad that I can just roll back to the last known working commit and then start again. So if that happens, I simply make another temporary commit, rebase in my changes, and then at the end of everything I'm doing, I already have worked in that I'm going to squash everything down to one commit anyway, so it doesn't bother me. All right. Assignment, while on main, update readme.md in the root of Megacort repo to do this one. Bada bam. Just after updating readme that the CEO approached you, stash the changes. Once you're stashed, make sure that they are safe in your list. Let's see, that they are safe by listing. Now it's okay. You would be able to see a single stash list. Okay. All right. Let's go into here. Let's go to readme. Let's see. Let's delete that and go to this one. There we go. GS. We have, oh, look at this. Look at this. We have our README, but bam, we got to stash some changes. So I'm going to jump in here and go. So for those that don't know, git stash, all it does is it takes whatever you were doing and puts it into like a special area. It's kind of like a commit. So if I look at git status, you'll notice there's nothing there. Git stash list. You'll notice that there is one right here. If we go git stash list, I believe it's -p. You can see the change right here. Right? It's just like a special place to be able to put changes for a moment. I never use it long term. If you use it long term, you're crazy. Don't do that. That's absolutely nutty to do. Right? Absolute nutty to do. All right. Stash has a few options. Git stash, pop, list. The pop command will, by default, apply your most recent stash entry to your working directory and remove it from the stash list. It is effectively undoes the stash command. It gets you back to where you were. This is called a stack, and that's important. Okay, pop your stash change back out. You should see it working. Git stash pop. So it's a stack, and that's really, really important to know because if you push two things on top of your stash, you will have your latest one on top. The stash command stores your changes in a stack, Philo data structure. Also, I wouldn't say Philo. Okay, I'm last in, first out. I'm more of a LIFO kind of person. Lane. Again, your copy editing hurts my feelings here. I'm a LIFO, not a Philo, or not a. I'm a LIFO, not a Philo. Yeah, for sure. That means that whenever you retrieve your changes from the stash, you always get the most recent changes. That's true. Bada bam. Philo is greater than LIFO. W lane. False. All right, stash is a collection of changes that you have not committed. They might be raw working directory changes, or they might be staged changes. Both can be stashed. For example, make some changes to your working directory, stash those changes. Make some more changes without staging them. Stash all of that. When you do that, the stash entry will contain both staged and unstaged changes, and both your working directory and index will be reverted to the state of your last commit. It's a very convenient way to pause your work and come back later. Git stash is a very convenient feature of Git in which allows you to store your index and your work tree into a special area known as the stash, and then later on to be able to pop off those changes and reapply them to your work tree / index. But what is the stash? Well, it's a data structure that is a stack. So every single time you have a change to your index / work tree and you want to save it for later, when you call git stash, it actually creates something that's like a commit and adds it to this data structure, pushes it onto the stash stack. Any files that were not a part of your index / the work tree will simply be ignored. When you call git stash pop, it's actually going to take the last thing that you added to the stash and apply it to your current work tree / index. That means if you stash 3 changes, A, B, then C, if you pop something off, you'll be popping off C. Then the next time you pop off, it will be B. Then the final time you pop off, it will be A. If you're unfamiliar with a stack, it's actually pretty simple. Think of a stack of plates. If I add a plate, then add a plate, then add a plate. If I wish to remove a plate, I would never try to grab from the bottom. I would just grab one from the top, then the next one, then the next one. Whatever order you put in is the reverse order of what you take out. In other words, it's a last in, first out data structure. You can inspect your git stash by simply executing git stash list, which will show you in the order in which you pop out your stashes. Often I use the stash in a very one-dimensional way. I have some changes that I need to pull in from main, so I'm gonna stash my current changes, pull them in, pop off my current changes, and continue on my work. I never use the stash as like a long-term storage place, just because my code changes so fast that it often gets out of date super quick. What is not staged? Unchanged, unstaged changes to the to the tracked working directory, staged changes, committed changes. You can't stage a commit, okay? You can't triple stamp a double stamp. If you push 3 sets of changes into the stack, let's call the first one A, the next B, the last one C. What happens when you run git stash pop? The changes from C are applied to your working directory, but the stash entry is not removed. The changes from C, I remember clicking this last time, it got me. The changes from C are applied to your working directory and the stash entry is removed. Let's go. Multiple stashes. You can stash changes with a message. I rarely use stash messages. In fact, I never use stash messages that I can remember. I've used it like once or twice. The big reason why I don't do that is whenever you're doing this means that you actually want to come back much later, which to me just says this needs to be a branch in which you keep somewhere, and then you can edit the commit if you want to. You can rebase the commit. For me, stashing is a very, very like temporal operation. Assignment: restash the changes to README with the message "Good marketing." Update the README file again with the following contents. All right. Git stash message good marketing. Boom. Right. And so we're going to go back here and I'm going to go delete and I'm going to have this one. There we go. Now let's see. Stash those changes with bad marketing. Git stash bad marketing. There we go. And now we should do a stash list. Git stash list. You can see these 2 different ones right here. So that means if you add a P in here, you can see the difference. Unite marketing, sales, and service in a single app. Try Megacorp Starter Suite today. There is nothing to install. No credit card required. The only thing standing between you and more customers are your terrible salespeople. Get started today. It's pretty good. That's a pretty good one. Feels good. Feels good about it. All right, so there we go. All right. Unrelated commit. Now that you've safely stashed your current work away, let's tackle the CEO's urgent matter. Megacorp's Apex script or shell script truly is a feat of engineering. It behaves exactly as the shell, born shell language. But with the word, but if the word shell or sh is ever mentioned in the standard out, it will replace it with Apex. It's a feature that customers love, but it's not working. Let's see, test by running scan with the Apex language for shell. There we go. We're going to grab this one. There we go. So you can see it right here. It's all right there. Okay, the grep command, let's see, the grep command should filter out the output to the lines that contain sh. You should see a couple lines, which means Apex sh isn't doing its job. The culprit is this line. Yeah. It should be replaced with sh, not bash. All right, we're going to update the script. We're going to update the script, right? All right, let's update the script. Man, customers love just the craziest things, huh? Scripts, Apex. There we go. Wait a second. There it is. We got the apex. Okay, you're right. Git status, git add this, git commit L. The L stands for lovely reading. ThePrimeagen. There we go. All right, now that we got that, apply without removing from the stash. So you can actually do that. I'm not really sure the purpose of this, but it does exist. You can apply without, or you can remove from stash without applying. This makes more sense. Lane W prime L. Yeah, I know it happened. Reference a specific stash, so you can actually do it in one of these locations with the @ sign. So that means we're gonna have to do the one run git stash list, sees the stashes you have, apply the changes from good marketing stash index without removing it from the stash list. So we just have to do a little apply, do one of these bad boys, git stash list, paste that in there. There we go. Git add your changes to the index, drop good marketing stash, pop the only remaining one, bad marketing. You should notice that you have a conflict. Resolve it by keeping the changes from good marketing stash. Commit the changes M. All right, let's do that. Git stash drop the stash at 1. There we go. Git stash or git add this. Git stash pop. Wait. Oh, whoopsies. Hold on. What happened? Git status? Did I miss what happened here? Vim readme. There we go. I missed the message that said it did the wrong thing. So there we go. I'm going to remove the bad marketing one. Call it a good. I missed the conflict message. How did I miss that? Oh, it's right there. It was right there the whole time. I just missed it. Again, it's that reading thing. You know what I mean? Okay, it's that reading thing that really gets me. Okay. All right, revert. When reset is a sledgehammer, revert is a scalpel. Revert is effectively an anti-commit. It does not remove the commit like reset, but instead creates a new commit that does the exact opposite of the commit being reverted. It undoes the change, but keeps the full history of the change and its undoing. So it's kind of like the Spider-Man thing. You know what I mean? Grug reading for a living, but Grug no read. Yeah, I know. It's sometimes you feel, right? All right. To revert a commit, you need to know what the commit hash of the commit you want to revert. You can do it with git log, all right? And once you have it, you do a little git revert hash with the commit-ish. Assignment. In your great haste and pursuit of greatness at Megacorp, you forgot to write a white paper and get approval from the L69 Distinguished Staff Architect for your marketing documentation change. The L69 has requested you revert the change. Ensure you are on main, revert commit M. It should prompt you to write a commit message. And we're going to call it N. Let's do it. All right. So we're going to go like this. Git log, one line. So what do we need? We need this guy right here. Bam. Git revert that one. N save. Git log, one line. You can see right here. Here, it looks like this. Git log, one line dash P2. So look at this. You can see that it's literally the inversion of it. The starter repo for the Git course 2. That one removed it. This one added it back. This one added this one removed it. This one added that one removed it. So it's like an inversion. So that's what a revert does. It literally does like an antimatter commit to your history. And then it turns it into a commit, so you actually have it as a part of your graph. Oh, shoot, that's not right. Right? That's not right. That's not right. Did I mess that up? I must have messed that up. Yeah, see, it says git revert M. Okay, that's my bad. Git commit amend. All right. There we go. That was my fault. Still doesn't read. I literally cannot read. The git diff command shows you the difference between stuff, differences between commits, the working tree, etc. I frequently use it to look at changes between the current state of my code and the last commit. I use it to look at. I primarily use it to look not at that. Yes, actually, that's exactly it. My current state. Sorry, that read funny. What my current changes are. I rarely use it for staged stuff. If you want to do staged, you have to do -- staged. Show the changes between the working tree and the last commit. You can do that. You can do difference between branches. You can do difference between two hashes. I've tried to do this for bigger ones and bigger projects. Once you get to a certain size, it's like impossible. Diff the changes between N and M commits. Remember, N is the reversion of changes M. Paste the full output in here. Git diff head ~1, I believe, is all I need to do. I think. I can't remember. Submit. Boom. Yeah. There we go. Bro, do you even diff? I diff. Okay. Just copy paste into Notepad++ with the differences extension. Wait, what? Why would you do that? Revert versus reset. Reset soft undoes the commit but keeps the stage changes. Undoes the commit and discards the changes. Revert creates a new commit and undoes the previous commit. There you go. When to reset, if you're working on your own branch and you're just undoing something you've already committed, say you're cleaning everything up so you can open a pull request, then git reset is probably what you want. However, if you want to undo change that's already on the shared branch, especially if it's an older change, then git revert is the safer option. It won't rewrite any history and therefore you won't step on your coworker's toes. Don't look at that. Don't look at it. When do you use revert versus reset? Well, they're actually quite different operations, so you just need to understand them fundamentally, and it'll become obvious when you use one versus the other. Whenever I use reset, it's because I want to be able to take a commit, undo that commit, make some edits, and recommit. And in the case of git reset hard, I actually just want to throw away that commit. This means I'm working on my own branch, not on a branch everybody else uses. I'm able to edit the history and get it into the way I would like it to be. Whereas a revert is more for the public branch. What this means is that you have a problematic commit and you need to be able to remove that commit, but you could never do that to a public branch because it's gonna break everybody. So instead, you make like an antimatter commit, right? This commit contains changes A, this one reverts changes A. And this also has the added benefit that if you want to go back in time, you can go back to A and actually fix the bug and then reintroduce A along with its bug fix. Now, I find that I revert when I'm on a larger team because often you're in this position where somebody needs this change to go out such that a new customer feature or a new A/B test that's high priority has to get out, but your changes have broken the build and were not discovered until we released into production. So we need them out right away. There is no waiting. There is no waiting to fix forward. So therefore, you simply revert your commit, fix the change, create a new commit with the fixed code and all the changes back in, and then next release your code can go out. And hopefully it's not broken. But if you find yourself reverting a lot, it's likely because you have a pretty unhealthy process. Your CI/CD is not up to snuff, your tests aren't quite there, your automation is no good. Production is the ultimate place to test, but it should not be the only place you test. Which creates a new commit? Revert, let's go. Which rewrites history? Reset. All right, there we go. Cherry pick. Everyone loves cherry pick. This comes a time in every developer's life when you want to yoink a commit from a branch, but you don't want to merge or rebase because you don't want all the commits. Git cherry pick is another one of these very useful Git operations, but you infrequently need to use it. Cherry pick is when you want one change from a branch, but you don't want the entire history of the branch. You only just want, say, a singular commit or two commits. Where cherry pick is obviously useful is when you have a branch that's called release, and then you have your main development line. Every now and then, release gets cut and that branch gets updated. Now let's pretend you've been going and there's hundreds of commit in main, but we discover a bug in production. Well, we can fix the bug in main and then just transfer over that one and singular commit to release and then re-productize release, thus fixing the bug, but we don't contain all of the changes from main because those changes are largely untested. Or maybe they contain half-baked features that are not ready to go out quite yet. So this is where cherry pick works. A switch to a new branch off of main called add partners, update the partners organization to be this one, commit the changes with O, update the same file again with P. All right, let's do that. All right, git branch. Let's see what branches I have. All right, cool. Git check out dash B. Still not doing it. Still not using it. Lane was just like, we should use switch. And I was like, dude, I'm all about that C. About that C. Git checkout. I just am. I can't help it. I can't help it. I just have to. All right, there we go. Won't sub if you don't use switch. Nope, then don't sub. I'll ban you. How about that one? How about that one, tough guy? Git commit dash O. Okay, the setup. We're gonna do the setup. My face. Yeah. Oh, wait, yes. So now we gotta do P. All right. Vim partners. Dap paste. Let's go. Here, git status, git add, git commit dash P. On the electric fence, huh? Little callback to Ren and Stimpy. I think I spelled fence wrong. Whatever, that's close enough. You know what? We're close enough. That's a little Ren and Stimpy callback, okay? It's been a long time since I've watched some Ren and Stimpy. Okay, close enough. All right, What theme of VS Code is this? You know exactly what theme it is. Can read nor write. All right, how to cherry pick. First, you need to clean working tree. No uncommitted changes. Identify the commit you want to cherry pick. Typically with git log is a good one. Run git cherry pick commit hash, or commit-ish would be better. Git log to grab the first of the two commits we just made. Oh, that's the one we want. Git log. There we go. I'm going to grab this bad boy, my O face. Then we're going to go in here, cherry pick O onto main, ensure that it worked by checking the partners one. Delete add partners. Boom. Git cherry pick that. Oh, I just did it onto my own thing. Git status. I didn't even change branches. Abort. Boom. Oh my goodness. I have a revert in progress. Oh my goodness. Wait, how do I have a revert in progress? How did I do that? Okay. When did I do this? All right, Han. Git log. All right, so I have the revert right here. All right, so that's already been committed. So that's not a problem. Git branch. We have our two branches. I'm on main. Let's see. No cherry pit. Oh, I have abort. Am I actually calling abort? Oh, dude, I'm so stupid. I didn't even see that I was doing abort. Okay, I am really not reading. It's been a long day. I don't know if you guys know this, but I've been streaming for track hours, 9 hours, okay? It's been a long day. All right, there we go. So I moved over this right here so I can go git log -p so we can see right here, closed ML, one of our favorite startups, right? Can't even read the timer. Okay, shut up. Shut up. It's been so long. I'm not good at doing this much stuff at a time. All right. We need to delete the add partners. Git branch delete add partners. There we go. The man's losing. I've lost it. I fully lost it. I've lost it. I've lost it. Let's go first try. Oh yeah, we're up to Bisect. Do you like Bisect? You guys want to Bisect? All right, so Bisect is fantastic. Let's do this, okay? Let's do this. Git Bisect is yet another Git command that does sound quite intimidating to the uninitiated, but once you learn how it works, it is actually quite simple. Git Bisect allows you to find a commit in which introduced a bug really fast. And it does this by using a technique called binary search. Let's just pretend that we have a branch that has many commits on it. Our latest commit contains a bug, and 100 commits ago does not contain the bug. How are you going to find when the bug was introduced? Well, you could go step by step through it until you find where the bug's at, but that would be tedious. If it takes a couple minutes per try, it could take all afternoon or multiple days. But since commits are ordered by time in which they are merged, we can actually pretend they are an ordered array and do a binary search across it. So this is how Git Bisect works. Let's pretend that we have a known state that is bad and a known state that is good. And we have a bunch of commits in between all of this. We'll call it X amounts of commits. If we test the middle commit, and let's pretend we found this middle commit is good, we know that all of this is good. In other words, we've cut our space in half. We have X divided by 2 minus 1 left commits to check. And if we repeat the process, we can continue on finding smaller and smaller regions to go check for our commits. If we find one of these are actually bad, then we know that all of this direction is bad. And we repeat this process until we're able to find a singular commit that is the commit in which the bug was introduced. If X was 1,000, it would approximately take us 10 checks to find the bug. And using Git Bisect is really simple. You set the good commit, you set the bad commit, you say start, and it will start doing that exact same process of cutting the known space in half, asking you if this commit is good or bad. If you answer good, then it knows all the commits earlier are good. If you answer bad, it knows all the commits that are ahead are bad. This can save you days of searching. So we know how to fix problems in our code. We can either revert the commit with the bug. This is more common on large teams, or fail forward by just writing a new commit that fixes the bug. This is more common on small teams. Well, if you have the time, this is the ideal in my head, is to be able to always fail forward, right? That is my favorite. But there's another question. How do we find where the bug was introduced? That's where git bisect command comes in. Instead of manually checking all the commits, that's big O, right? Big O-N, I mean. Git bisect allows us to do a binary search, which is log n. So that means after 10,000, it's only 14 checks. It's the way to go. So if you don't know how to do bisect, bisect is fantastic if you're working on a slightly old code base that has thousands or hundreds of commits, right? All right. Let's see. Bisect isn't just for bugs. You can do anything. So the nice part about this is anytime you have a change you're looking for and you have a script that you can check, then bisect can be used to find where that, say, improvement and performance improvement was introduced, performance regression was introduced, anything. So bisect is fantastic. The purpose of bisect is to split the repositories in two separate repositories, split the commit into two, find a commit that introduced a bug or change. Say it that way. A commit to find a change that was introduced. There are 7 effective steps to bisecting. That's it. There's only a quick 7. Now, you know me from reading, right? Am I right? You know my skills at reading, so we're about to go deep on this one, okay? Yeah. All right, start the bisect with git bisect start. Select a good commit. Select a bad commit. Git will check the commits between them and find it. Execute git bisect good or bad to say the current commit is good or bad. Loop back to step 4. Exit with this one. Git bisect reset. There we go. Assignment. Your boss just chewed you out because the scan sh script should never have been added to the repo. Not only does she want the contents of the script erased, but she wants to know when the script was added, and for you to fix it with git revert so the history of your royal screw-up is preserved. Considering you can't remember when you wrote the script, you decided to use git bisect. Start bisect. You know the head commit is bad, so mark it as bad. You know the first commit A is good, so mark it as A. If the script content is present, not just a to-do comment, mark the script as bad. Otherwise, mark it as good. Repeat step 4 until git bisect completes. It should give you the hash of the commit. All right, so this should be pretty easy. Do you understand here? Right? Boss should have been in code review. Yeah, I know, boss yapping, but boss wasn't reviewing. That's what I'm seeing right now, people. A lot of yapping, not a lot of looking. All right. Let's see, revert the commit that introduced the script with commit message P. Am I right? All right, so let's find out when that happens. So we're gonna go like this. I'm gonna do the following. I'm gonna go git bisect start, right? So we're gonna start it, waiting for both good and bad commits. So I'm gonna go git bisect bad. So that just says, oh, did I? Bisect, there we go. I literally could not see the difference there. Bad. So you don't actually have to provide a commit if you wanna use the current one. So there we go, I just used the current one. Git log one line, go all the way down to the bottom. Git bisect good, we know is somewhere right there. So now, notice that it has 6 revisions left to test after this, roughly 3 steps. So we can go cat scripts scan word count line. All right, so there is 1 line. So this was just the to-do, right? So when it has 1 line, it is the to-do. Okay, so that would be git bisect good. We like that one. This one has 10 lines, so that one's bad. This one's bad. All right, this one's also bad. All right, this one's good. I'll explain what's happening in more detail here for a second. There we go. You can see exactly where this has happened, and you can even see right here, K credits. So, all right, I think this is good. Git log -p, this thing. You can even see right here, this is where the changes were made to the scan script. So what actually happened there? It's actually not that bad. You can imagine that at A, that's our first commit, and I forget what our head is, right? Whatever commit that was, head. How a bisect actually works is that, remember, each commit has an ordering to it. This is an ordered array. Therefore, the ordering, of course, being merge order, or it's going to be like, say, time. And so that means we're going to go B, C, and all the way up to head. That means if we check the middle element and it's bad, that means this entire side is bad. But if we check the middle element and it's good, that means this entire side is good. So since the first one was good, we know that all of this. Let's see, hold on. Shoot, which one is that? If we know this one was good, we know that the rest of these were good right here. So that means we went in the middle of this one. So then when we checked here and it was bad, we knew that all of these were bad. So then we went into the middle right here. And when we checked this one, since it was bad as well, we knew that all of these are bad. So we went and checked right here. And since that one was good, then either the one right after it, since there's only one commit left between these two, it was able to say that this one was the bad one. It's a binary search. That's effectively what happened. All right. Sorry for my fairly shoddy explanation, but that's all it is. Bisect is really simple. Right? It's really easy. You can think of this like an ordered array. Imagine you have an array that goes 1, 2, 3, 4, 5, 6, 7, 8. And you wanted to find out if it has the number 6. Well, what you could do is if this is 0 and this would be 8, right? The ending, it's of length 8. You could do 8 minus 0 divided by 2, which gives you 4, and you can check this one. Is this 6? No, it's not. Is it greater than it is? Since it's greater, we need to check this one. Okay, that means we need to update our lower bound to this one. So now that's going to be 3. 0, 1, 2, 3. We still have 8 as the length. So we do it again. What is 8 minus 3 divided by 2, which is going to be what? 2.5, 2. Then add it to 3, so we got to go to 5, which is going to be 4, 5. Is this one it? Yes, it is. We're done. Say we're looking for 7, then we do the exact same thing again, which we'd have to go to 5. 8 minus 5 is 1. Divide by 2, that's 3. Divide by 2, that's 1. Add it to 1. All right, 7. Check here. Is this it? Yes, it is. Good. So that's all it is. It's pretty easy. Binary search is really, really easy to do, right? And it's great. It's actually really, really great. So that's all Bisect was doing, was that. So now that we have that, we're going to go like this. Git bisect reset. Oh my goodness. Bisect. I can't read that word. Git revert that one. P. There we go. Sounds like successive approximation. Well, whenever you have an order, you can search the space more efficiently given input. If you don't have an order, you cannot search space efficiently. That's why things like, that's why eventually you just have to do a linear search through everything if you have no order. Linear is quote unquote slow. Linear is slow, but it's not as bad as like quadratic or even more. That was annoying. Now imagine if testing wasn't as simple as just looking at a file. Manually running an automated test can take a long time as compiling. A Java enterprise project, absolutely. From the man Git bisect, you can do bisect run. Now this is cool, okay? Bisect run allows you to be able to do that process we just did, but in an automated way. Now this is very important because sometimes you have to sit there for 30 minutes for something to tell you if it's correct or not. So it's much nicer to be able to just have this thing run and then you go play, I don't know, play a game of basketball, whatever you do. I'm not sure what you do, okay? So there we go. There we go. Let's create a new script in scripts called bisect, sh, with this contents. So that means if we find scanning in the scan, we exit with a bad exit code. If we don't find it, we exit with a good exit code. In other words, bisect, when you run, it uses the exit code to determine if it's a good or bad build. So let's go in here, vim this thing up, go into scripts, go bisect.sh, go in here, do that, make it executable. I prefer to hit oh yeah, I guess I don't need to do a shebang. There we go. And now I can go into here and do the exact same thing, and I can run this script now. So I can go like this. We already chmoded it. We can do a bisect start. We can go git bisect start, git bisect bad, git bisect good, that. There we go. So we have our head to our tail, and now we're going to run through and do this thing. Even though technically we're doing a bad with our current one, there's a little bit of something weird here, so I can go, because we reverted it, so technically our head breaks our whole ordering, but don't worry about it. We can skip that. Git bisect run scripts bisect, and I believe we don't need to, yeah, there we go. We don't need to provide any arguments, so when we do this one, there we go. It found it. It is able to run that script super fast and find it immediately. There we go. And now we know where the problem was. See, bisect's pretty cool. What does automating bisect require? An automated test that can programmatically inform Git if the current commit is good or bad. That's pretty much it. There we go. All right, Worktrees. We've been saying Worktree all throughout this course, but I have been misusing it. I am sorry. It's not, technically what we're on is not called It's not work tree precisely. It's the main work tree, which is more precise because you can have more than one working tree. But what is a work tree? A work tree or a working tree or a working directory is just the directory on your file system where the code you are tracking with Git lives. Usually it's just the root of your Git repo where the .git repo is. It contains tracked files, untracked files, modified files, right? Everyone can fundamentally understand what a work tree is. Your main working tree just makes sense. The work tree command. Git has a work tree command that allows you to work the work trees. The first subcommand we'll worry about is simple. Git work tree list. It lists all of the working trees you created. All right, so let's see what working trees we've created. You'll notice there's only one working tree. Right? Yeah. Which is my current work tree, right? Linked work trees. We've talked about stash, temporary storage for changes, branches, parallel lines of development, clone, copying an entire repo. Work trees accomplish a similar goal, allow you to work on different changes without losing work, but are particularly useful when you want to switch back and forth between two change sets without having to run a bunch of Git commands, not branches or stash. You want to keep a light footprint on your machine that's still connected to the main repo, not a clone. So this work trees effectively allow you not to have to clone out a repo for a second version of it. There's some requirements, there's some rules. I think I go over the exact rules in here. The main work tree contains a Git directory, that's important, with the entire state of the repo. Heavy, lots of data in there. To get a new main working tree requires git clone or git init. A linked work tree contains a Git file with a path to the main working tree. It's effectively as light, you can think of it as almost as light as a branch. It's just a little bit heavier than a branch. Let's see. Can be complicated to work with when it comes to end files and secrets. This is where things kind of usually go off the rails for work trees, is work trees can be a pain in the butt when you have, say, node modules. Node modules can be really annoying. So we can create a new work tree like this. We do this. Whenever you do a path on an add, if you do not include a branch name, it takes the first baster of the path and uses that as the branch name, and it'll actually create it. So we can create a linked working tree as a sister directory to your main working tree called UltraCorp. Use the default UltraCorp branch. So watch this. So I can go git bisect reset. Forgot to do that. Git work tree add. What is it? It's path, which is going to be, let's call it UltraCorp. There we go. So prepared a new work tree. It's called UltraCorp. So if I go here, back out and go UltraCorp, you'll notice that UltraCorp is on branch UltraCorp because that was the first baster of the path that I did. So if I would have done UltraCorp/foo/bar, then the branch would have been bar. If that makes sense. And so now if I go like this, cat git, you'll notice it's literally just a pointer to where it needs to be. Right? So there it is. Primeagen personal megacort git worktrees UltraCorp. So it's saying where it's located at. Pretty cool, right? I've been programming for 12 years, and I like to think of Git as magic under the hood. It's really, it's shockingly, it's not the most complicated piece of software. I'm sure the actual operations for creating and deleting files and stuff like that is complicated, but everything else is, how it works is actually not the most, oh my gosh, how could this possibly be? Right? All right, no duplicate branches. Linked work trees behave like normal Git repos. You can create branches, switch branches, delete branches, create tags, etc. But there is one thing you cannot do. You cannot work on the branch that is currently checked out by another tree branch. Navigate to UltraCorp, attempt to switch to main. So when I try to switch out main, it says already used, right? Makes sense, right? Yeah. Tracking. So how does your main working tree know about your linked working tree? Well, the reference is stored in Git Worktrees directory. List the contents of this directory. So if we go like this, if we go to here and go ls-la git worktrees, this is a new one. You'll notice that UltraCorp is right here. So if I go in here, you'll notice that it has effectively the entirety of everything you need to know about it. Where its head is pointing, it's like a little mini Git experiences going on right here. And it even has a git dir. And you'll notice that the git dir, if we look at it, will actually be like the inversion of the other one. Whoopsies. There we go. Oh my goodness, how did I get that? There we go. It's the path to where we're going. So that's how it know it exists. That's why when I go work tree list, it's able to actually find this. If I were to delete UltraCorp, it'd actually say like dead or prune or something like that. Removed. I forget what it says, but it says something. How does the main work tree keep track of it? The main working tree, let's see, the work trees directory contains references to them. Yep. Megacorp's IT staff manually logs it in Jiro, their project manager software. Actual magic. Which one is it? All right. When you make a change in a linked work tree, the change is automatically reflected in the main work tree. It makes sense. The linked work tree doesn't have a Git directory, so it's not a separate repository. It's just a different view of the same repository. You can almost think of a linked work tree as just another branch in the same repo, but with its own space on the file system. Run git branch on your main work tree and answer the question. So if I go like this, git branch, look at that. You can even see the little plus sign right there. That's because it's being checked out in a work tree. It's kind of a fun thing. How can you tell if a branch is checked out in a different work tree? The branch will have no prefix that has a plus prefix. Let's go. Plus prefix. Let's go. Deleting work trees. You may never need the stash again. This is the nice part about working with work trees is you don't actually ever need the stash ever again. You can have two work trees that are always, you can switch between them. You can always check out a new one every time you work on a branch. I had somebody at my old job tell me that stashing or switching branches is an anti-pattern. You should just always work tree. Anyways, however, at some point you need to clean up your work trees. The simplest way was to remove the subcommand. You can do a remove, but you can also do something cooler, which I actually prefer. You can just delete the directory. Watch this one. Let's see, hold on. Does it say that? Remove UltraCorp. Cool. Git rm rf back UltraCorp. There we go. So if I go git work tree list again, you can see this right here. See, prunable. I knew it said something. I couldn't remember the word it said. But now that means if I go git work tree prune, it's able to tell what to prune. Because remember, when we did this, when we catted the gitdir, UltraCorp had a directory. So when it goes and it goes here, it cats out this thing. It stats that file. When that file doesn't exist, then it knows that it doesn't work, that this thing has been detached. What about NPM modules? You have that. I mean, you can copy, you can create a script, right? I talked about that. The whole environment part of work trees can be difficult, right? There we go. Bam. I always had like 2 or 3 working trees, and I would actually just switch between them. So whenever I needed to do something, I could actually just grab that and change it. All right, tags. We're going to wrap up this course with an easy one, tags. Tags, again, I showed this at the very beginning of the course. Tags has the craziest user manual, but it's so simple. To list all the tags, you can just do git tag. So git tag. I have no tags. Very, very easy. Tag is just an immutable pointer to a commit. Very, very nice. We can create a tag by just doing this. Tag A, give it a tag name, give it a message, all of that. All right, create a tag on the latest commit P with the name candidate and a descriptive message. All right. Git tag a, let's see, so we can go git tag -a if you want a name. So the name can be candidate, like that, right? And then you can do a message such candidate. Boom, git tag. Look at that beauty right there. You can also, if I'm not mistaken, you can also create a tag without having to do this, right? There you go. You don't have to use -a. It's like the default first parameter. There you go. Now tags, remember, you cannot edit a tag. So when I check out a tag, git check out tag, git check out candidate, I go into a detached head state. Like you can't make edits to a tag. Tags are immutable pointers. It's very important to remember that. And also, one last thing, git log, one line. You can also see tags when you have decorations, which is nice. Why would one use a tag? Oh, very, very simple. Let's go like this. Let's go to GitHub React. Let's just go check out the React library. Let's check out what tags they have. Tags. Do those look familiar? If you've kept track at all, React server components exist in 18, right? People typically use tags to point to versions that are released in public. So this is like a very normal behavior that you should see tags for. They're usually some sort of release. Now you can do stuff with Semver. This is typically how people do this with just Semver. It's kind of weird to just name tags any old thing. We're developers. We like structure, sameness, and sometimes even bike shedding. Oh, I love bike shedding. Semver, semantic versioning, is a naming convention. By the way, I've been bit so hard by Semver because of this one right here. Minor sometimes it isn't a safe feature if people change default parameters. Just so you know, default parameters don't technically break major versioning of Semver and can screw you. Just so you know, just in case you're wondering. Note, V isn't actually a part of the Semver. Correct. This means a change to the API in which will break compiling code. Minor means an additive change to the API that won't break code. Patch means no change to the API at all. There you go. That's the easiest way to say it. Let's see. To sort them from highest to lowest, you first compare the major versions, then minor versions, then finally patch versions. For example, major version 2 is always greater than major version 1, regardless of the minor version. Absolutely. If I'm using some code that's on V124 and I see a new version 224 is available, should I expect to be able to safely upgrade without making any changes to use it? No! Major versions are not backwards compatible. Or typically are not backwards compatible. Good thing to know. You know what I mean? Good thing to know. What's the highest version? 422? 422. Let's go. I'm so good at this. Conventional tags. Tags are used for all sorts of reasons, but sometimes they're used to denote releases. In that case, tags follow the Semver are common right here. So tags, this is very normal, right? Fun fact, pretty much anywhere you can use a commit hash, you can use a tag name when working with Git, right? It's a commitish. Let's see, assignment. Add another tag to the same latest commit, right? Commits can have multiple tags, which we already did. And then there we go. Boom. Git tag v 1.0.0. That'd be like, oopsies. That'd be like a normal one. Git push tags. There we go. Push them all up. Let's go. Got it. Tags. Okay, guys, stop making fun of my tags. There we go. We're done. I just did 2 Git courses. Thank you very, very much. I hope you enjoyed this presentation of boot.dev, Git's course in which I helped create quite a bit. The name is ThePrimeagen. Boot.dev/prime. Use it!